Yeah, yeah, yeah. Yeah. Better off, better off. I am wicked, you're insane. But I wouldn't have it any other way. If we're knocked out, we'll go the distance. Pound for pound, we're a perfect match. Pulling punches, or toe to toe, we're always on the road. Worse or better, we can't stop, we can't stop. 'Cause together, we're better off, and we can. Better off, better off. Better off. I am crooked, you're clean cuts. I'm wide-eyed, your eyes are shut. If we're knocked out, we'll go the distance. Pound for pound, we're a perfect match. Pulling punches, or toe to toe, we're always on the road. Worse or better, we can't stop, we can't stop. 'Cause together, we're better off, and we can. Yeah, yeah, yeah. Yeah.
Let's make this one. Let's make this one. Money. Money.
as days passes by, and most long for a place that they never find. I'm afraid I wake up when I die, and it is too late to climb any mountain. Time is of the essence, the blood running through our core. It's best to not feel sorry when it's over. I will be the greatest that you've ever seen before, and I'll stay eternal. Sometimes I feel that my luck's run out. When things don't go to plan, I kinda lose my mind. I hope it's real, this life comes around. Just keep your faith and search for the fountain. Time is of the essence, the blood running through our core. It's best to not feel sorry when it's over. I will be the greatest that you've ever seen before, and I'll stay eternal.
Hello everyone, I am back. It is Wednesday. I ended up missing the stream yesterday. I was working on some stuff and was just in such a groove or whatever that I needed to keep working on that at the moment when I was normally scheduled to start streaming. So I decided to keep on that roll basically. Sometimes when you're programming and you've got a lot of stuff going on in your head and you don't want to have to get back to that point the next day or whatever, it's better to not stop at an, just an arbitrary point in time. So apologies for missing that stream where we were going to do the x86 instruction decoder work. Again, we'll have to work on that tomorrow, I guess. Yeah, so this stream, this is normally the day, one of the days of the week where I would work on practicing binary exploitation, going through the nightmare course that I had been going through, and it's what am I saying? That's, I'll probably still do that, but I want to try something else in the meantime. Or I want to talk about something else, I guess, that sort of relates to the other stuff that I've been streaming, the x86 decoder, not necessarily the Try Hack Me stuff. That's more just for fun and to be a little more accessible to the folks who have worked on, or have watched the stream rather, not worked on the stream. Sorry, I don't know, I'm distracted in my thoughts right now, so I'm a little saying stuff that's not related to what I'm thinking about and then getting my sentences all messed up. So yeah, what I want to talk about relates to both the practice that I've been doing with the Nightmare course and all this binary exploitation stuff, and the x86 decoder, and one of my motivations for working on that. Not necessarily the number one motivation, which is really to just learn how x86 instructions are encoded in the binary format, but one of the sort of secondary motivations that I have for working on that project was, for a long time I've wanted to create some kind of introductory material, educational course, like do curriculum development, course development work for an introduction to hacking that is kind of along the lines of how I view hacking and what the things that I think are important and what I think would be a good way to learn that stuff, let's say. There's a lot of material out there already, obviously, and for me, for my sort of mindset, I wouldn't want to just have, the 500th introduction to how to do a buffer overflow in x86, in a x86 ELF binary, for example, something like that, because there's so many of them out there. Just doing another one doesn't necessarily add to anything. In fact, it might detract, because from my experience, when I'm in a situation where I'm like, okay, I want to learn this skill, and then I go on Google and I find dozens and dozens and dozens of different tutorials on how to do that thing, there's two negative results that come out of that a lot of times. One, I'm just left with this like choice paralysis. I don't know which of these is going to be better or worse. I have no ability to assess that because I don't know the thing in the first place. But I am suddenly presented with the choice between all of these different ones. And obviously you can just pick one, try it, see if it helps for you. If not, pick a different one and try it. It's not like the worst problem in the world. I mean, it's certainly not as bad as having no options. But it's if I'm not making a meaningfully different contribution, then I'm just adding to that choice paralysis. I'm just one more entry that somebody has to then expend mental effort considering, is this the one that I want to use to try to learn this thing? And then the second negative outcome that I see a lot, it's not exactly connected, but it just seems to happen a lot when I'm in that, or I see it a lot when I'm in that situation where I see a ton of introductory material on something. Suddenly, once you get past that introductory material, the number of options that go beyond that seems to drop off drastically. So you could probably, this is probably just true in everything, but if you consider programming, for example, you could find 1 million Hello World tutorials for JavaScript, and you could find, several, like 1,000 how to make the most basic, maybe Hello World style or to do MVC style JavaScript application with React. But then, how do I make a more meaningful application with React? Suddenly you're left with maybe a small handful of, multi-post blog series or a book or two that have been out there, because it's actually just a lot more work to get past that very basic intro thing. And I think the result of that is, like, somebody has learned the basics, and maybe they've learned more than the basics, but certainly they've learned the basics, and then they're like, okay, I want to give back. I want to share this knowledge that I have, because I know how to do this thing. Let me teach other people how to do it. So then they write a thing that's the bare, earliest stage hello world kind of basic thing. And either that's what they currently know, so they can't actually explain and teach more than that, or they know more, but then they start to realize, oh, it becomes significantly harder to teach beyond just that first step. And you just see less and less actual educational material that, goes beyond the basics, essentially. And I don't want, having that experience, I don't necessarily want to contribute to that situation by making, yet another standard, very much the exact same thing as other curriculum, introductory post or whatever about how to do a buffer overflow, for example, how to exploit a buffer overflow rather, and then not follow it up with anything after that to compound on the problem. So, but at the same time, I do really want to share what I know, which is not, I can't claim to be some kind of expert hacker by a long shot, but I feel like I know enough that I could present. Ideally I could show enough to teach people up to what I know, which is not nothing. And I want to show it in a way that corresponds to sort of my own philosophy of hacking and programming, because I'll get into that a little bit later, but I want to pair those things and really have it speak to my own, and not just, okay, here's a how to do this thing, but here's how to do programming, or to do hacking. And when I say hacking, in this case, I'm really talking about like exploit development, maybe vulnerability analysis, and then the development of an exploit for a particular vulnerability in a program. So this is setting aside the broader scope of hacking, the kinds of stuff that we see when I do the Try Hack Me streams, where I have to do enumeration on a machine or a network to find the machines, and then enumerate the individual machines for what ports they have, connect to those services, try to enumerate what is available on those services, and then figure out what the vulnerabilities are by maybe searching public databases, maybe doing some manual sort of investigation, vulnerability assessment perhaps would be the correct term there, where you're like, okay, maybe there's, maybe this input is vulnerable to a SQL injection. Let me run SQL map on it and find out, or let me just manually try some SQL injection kind of attacks. That sort of thing, right? So that's all leading up stages, and a lot of times when you're doing that work, you might just be using pre-built exploits, something in Metasploit that's like got enough of a proof of concept there to be able to load a payload on the target machine if it's an RCE or something, or get you the privilege escalation. So somebody else has done the work of building the exploit for whatever vulnerability. Maybe they didn't, maybe they found the vulnerability themselves, maybe they didn't, but either way, that side of the task is usually what has already been done if you're on the side of, doing maybe a certain tier of pen test analysis. Maybe that might be too broad of a statement. Maybe the pen testing does involve actual like vulnerability assessment and exploit development after finding those vulnerabilities. But yeah, what I'm focusing on with the term hacking is really more in line with the binary exploitation stuff that I've done on those streams. But I don't want to call it binary exploitation, because I do think that is just one particular form of it, and very crucially, not the form that I want to start off with in teaching. So now maybe in my rambling, I'm sort of getting to more of what I talk about when I say I want to have my philosophy in the course that I would like to develop. Some of it is literally my philosophy in terms of my thinking about what hacking is, how it relates to programming, that kind of thing, but also my philosophy of pedagogy, of curriculum development, which comes out of, a relatively short period of time, 3.5 years, where I worked teaching software development at a boot camp. And this was like teaching people usually one-on-one, but also in the process creating projects for folks to work on, like lab projects, basically trying to understand how to structure those, trying to understand how to structure the curriculum. And because of the particulars of our scenario and how crunched we were for time, I think even though that's not a very extended history in education, I do think that we, as myself on the team and then the team as a whole, had such a strong focus on how can we optimize the the pedagogy, basically. How can we design this curriculum to achieve our sort of learning goals for the whole 6-month period that the curriculum was, and that's 6 months of roughly 9 to 5 every week. So it's quite a bit of education packed into those 6 months. How can we best get to those learning objectives? Because there's, we're only selecting a subset of the things that we really should be teaching in order for somebody to then go and get a job as a software developer. And we have to select the ones that are most critical. But if we can optimize that, if we can figure out a way to ease the process of learning those things for our students, then maybe we can get a little bit more teaching in. Maybe there's, essentially better outcomes that we can get. And I think we definitely improved over the years that I was there. And hopefully they continue to improve on that as well. I would assume so. So what comes out of that is I definitely have a lot of opinions on how to structure curriculum and how things want to build on each other in order to best provide a smooth learning experience. A learning experience that is challenging, but not defeating, let's say. So it needs to involve frustration, fundamentally, I would say. I mean, that's not the goal, but much like if you are working out and you aren't feeling particularly sore or stressed or whatever, like you're not feeling tired from working out, for example, let's say. Maybe sore is not the right phrasing of that. But if you go to the gym and you work out and you don't feel tired afterwards, then you probably didn't push yourself hard enough for that result, for that time to have been meaningful in, your progression of fitness or whatever. In the same way, if you're really learning something, if you're really pushing yourself to understand something more than you did before, it's going to be uncomfortable. I guess that's the no pain, no gain is really the more fitness-oriented phrasing of that. It doesn't feel great to have to lift more weight than you were able to lift before. It feels good to accomplish it, but the process of doing that is uncomfortable. That is because you are growing and pushing your body. And the same thing is absolutely true with learning. It just feels uncomfortable to learn a new thing fundamentally, because in the moment of doing the learning, you don't know it. You haven't learned it, but you are attempting to do a thing that you don't know how to do. and you can see yourself fail, and you can feel that you didn't do it correctly, and that feels uncomfortable. But that's a necessary piece of the process. You can't actually skip that and then just know the thing. Unfortunately, the whole Matrix style, like, just download the knowledge into your brain is it doesn't exist. I wish it did. I wish I could learn kung fu like that, but turns out you gotta go through the painful process of actually practicing and being bad, and practicing and being bad, and practicing and being a bit less bad. So recognizing that it's going to be frustrating, you still want to design it to not be, to be as, like, for whatever pain you have to pay, you will get the most gain, so to speak. So if you were training to be a boxer, for example, which is maybe a little bit more of a better corollary with the hacking thing, because there's a little bit of an adversarial nature to that concept, even when you're training against a dummy or something. There's a, it's not necessarily the same as lifting weights, which is more focused on yourself. You can be, you're in an adversarial position with the program that you're trying to hack, for example. Maybe that's how you would phrase it. Or you could be in an adversarial position with a CTF scenario, for sure, and especially in the attack defense style of CTF. But so if you're training to be a boxer and your instructor says, on day one, I'm going to put you in the ring with this guy who's been working out and learning boxing for the last 6 months, and then you get your face mashed in, because that's just, unless you have some absurd preternatural talent for it, that you're not gonna do well in that scenario. And so that sucks, and that's painful, and that's the frustration of learning, you could say. But then you go back the next day and your instructor says, okay, we're going to do the same thing. You're going to go in and you're going to fight this dude who, again, is way more experienced and capable than you are. And that's the whole learning process. That is not an optimal learning process. You might learn, it's not necessarily the case that you wouldn't learn anything from that. But what you get, the sort of percentage of learning you get for the amount of pain that you're feeling from that process is not optimal. This is sort of my way of looking at it. So curriculum development has a lot to do, or curriculum design and all that has a lot to do with how to figure out an optimal pathway to learning that information. You're never going to get the most optimal, because that's really entirely person to person based. Like the best scenario is to have a tutor who can really empathize with you and understand and get in your head about what you currently understand and how you understand it, and then work from there to figure out what the correct curriculum for you is, and do that as a continual repetitive process. Or iterative process, I guess. But barring that, if you are trying to build curriculum for a broad group of people, you can still apply these same goals and principles around how can I figure out what the audience most likely knows by now, and then build to the next thing based on that, and the next thing based on, continue. So when it comes to curriculum development, this process is really about figuring out what the fundamentals are, figuring out how to separate those fundamentals into individual sections or pieces that can be understood on their own, or are a sort of a single added thing on top of what the student already has an understanding of. Whatever their current level of understanding, if you can determine that through some means, and that's a whole separate piece as well in the curriculum development process. But if you can have an understanding of where they are at by now, if you can figure out what's an additional piece that we can add that's just one thing, that's going to ease the process significantly versus, okay, let's have them do another task, and that task happens to involve 2 or 3 or 10 new skills that they have to apply, and none of those are skills that they are experienced in. It's going to be vastly more frustrating because they're going to have a lot of trouble understanding how those skills differ and relate to each other, because they don't have the framework in which to even quite piece out that those are different skills. You can maybe tell them in the curriculum and say, okay, we're going to learn X, Y, and Z skills now, or they'll, these skills will be things that you have to employ in solving this challenge, for example. They probably still won't have the experience to be able to say, oh, when I did that, that's definitely this skill. And when I did this other thing, that's the, skill Z or whatever. And when I did the third thing, it was actually skill Y and skill Z together that I was using. Ideally, they can do that, but I think my experience says that's a far from a guarantee that you're going to have a student that has that sort of either just existing experience or happens to be particularly good at that. I mean, maybe in some cases it's going to be easier than other cases for anybody to be able to like parse out this skill versus that skill kind of thing. But if you put them together, they become muddied in the student's mind, and then you need additional work to disentangle them. You need additional work to, begin to understand how they relate to each other and are different. And then, separate from that, another piece that makes it frustrating for the student is when it doesn't work, they don't necessarily know which of those skills are related to the piece that is making it not work. So you're just adding more complication onto the problem of learning by sort of designing a challenge or a task or whatever means of practice and assessment you have you're making it more difficult by having that involve multiple new things at the same time. So that, at least that's like a fundamental principle of my own personal beliefs around curriculum development, is that you want to try to teach one new thing at a time. And then the additional thing that pairs with that is figuring out how to order those things in a way that is most conducive, that doesn't involve gaps, that doesn't involve somebody learning a thing before learning some other thing that would actually make it easier to understand that. It's maybe not something that is dependent upon it, but like if we want to get into some details, like learning about buffer overflows before you have learned about how the stack works is going to make learning about buffer overflows significantly more difficult. You could probably muddy your way through it and sort of just gain enough of a understanding of the operation of the stack in an x86 program or generally any sort of actual machine architecture application. So you could like, if you just push towards learning how to do a buffer overflow, you'll out of necessity learn something about how the stack works, because they're so interrelated, those two pieces of knowledge. But if you already had a clear understanding and a grasp of it that reached almost the level of being intuitive for how the stack works, actually learning how to achieve and then perhaps separately exploit through like shellcode or whatever a buffer overflow attack, you it'll just be that much easier, basically, because you aren't also trying to add in the let me understand how this concept of the stack works, and the the stack pointer and the memory addresses that are involved in that, and how things get laid out and all these related pieces. So, for example, if somebody were going to teach how to do buffer overflows, it would be particularly meaningful, or helpful rather, to spend, I would say, a fairly significant amount of time focusing on getting that intuitive understanding of the stack. And I don't think that's something that I have necessarily seen, at least to the degree that I would advocate or prefer, from the, sort of hacking binary exploitation educational material that I've seen out there. So that sort of like comes into why I would like to develop some curriculum, and why I think my approach at least is different enough to warrant actually doing it, rather than, as I said at the beginning, just adding another, like, the 100th, 500th, whatever, tutorial on how to exploit the first, the most simple buffer overflow, for example, and how to do, basic shell code. And like, a lot of those I've seen are just going to give you the shell code in the first place. So, they aren't even necessarily, they're at least understanding enough that like it's not going to be helpful to also add that set of skills onto the whole understanding of the buffer overflow mechanic and the stack and all of that. They at least have a recognition is the word I was looking for, that also then understanding the behavior of assembly code, how the control flow is being hijacked and then operated by you as the attacker, the whole, essentially weird machines concept being employed. So what would make my approach different is that it would start way earlier than that. Buffer, like doing the kind of buffer overflow thing that you can find a lot of these tutorials for, I think would be, it's hard. I don't understand enough about what the curriculum is going to be in order to put what percentage of the way through it that would come at, but it would be after quite a number of other pieces that taught sub skills that are involved in doing that. Because I think you can take that task and break it down into probably at least a dozen different skills. And then each of those skills could be taught on its own with the right tools and the right projects. And that's the most difficult part. It's difficult enough to take that and break it down and figure out what all the actual skills are, because this is sort of what I had to learn how to do to some degree. I wouldn't say I'm not going to say that I'm perfect at it, but when I was teaching the students in programming is something that I've done for a long time. And a lot of the things that I do in programming have simply become unconscious. They're like the process of seeing bugs, fixing bugs, et cetera, as I develop the software and then iterate on it and write more code and then have a bug and then see what that bug, the error message or the resulting bad behavior or whatever, and analyze the structure of the program and the behavior of the program in my head, and then come to a conclusion about what the failing piece of code is, what the bug is, and then correct it. Like, I can do that much faster than the students can, because I have internalized so many of those skills that are involved in that process. And so when I'm trying to teach it to the students, it was really critical for me to be able to take a deep assessment of my own process and try to break that down into what are these particular skills that I am employing, so that we can make those as explicit as possible for the students, ideally teach them as separate concepts that they can practice individually and then practice putting them together. And so that process of like trying to figure out what is it that I do when I program, so that I can tell them what to do when they program, not just the concepts of how coding works and how what these ideas in the language are and how we can construct programs, and that's a whole separate set of things. But there's also just the fundamental task of writing code, the iterative process, the manual, separating, like if you think about I don't know, constructing a cabinet or something, there's the design of the cabinet, but there's also the physical task of creating the individual pieces and then putting those pieces together, making sure that it's properly assembled and securely fastened together, however that works. It's sort of checking it for stability and stuff, the testing aspect that comes in programming. So in the same way programming has, the more design oriented mental pieces. I mean, it's all technically mental, but there's more like just think about it kind of tasks. And then there's also this operation of the computer and going through the process of trying to craft the code itself, that achieves the particular goals that you have designed through the thinking part of the process. And, what I was talking about earlier is like, you can also break that whole process down into pieces and try to teach those pieces to the students, because they will come up with their own process for doing that, but they might miss a lot of things and they might do it very like suboptimally. And if you can nudge them in the right direction, I mean, they're not going to like instantly do everything the right way just because you've told them here's a thing that you should be doing. But if you can understand where they are differing from what you see as the correct way to do it, or at least maybe not correct, but like the way that you have figured out how to do it that is seemingly more optimal for you and probably would be more optimal for them. If you can analyze those things and really understand and introspect on yourself about what those things are, then you can better teach them to the students. So all of that diversion is me talking to the idea of I want to analyze for myself the same, like analyze my own process of doing binary exploitation development, what I've been doing on those streams where I go through the nightmare course. I want to practice that, or rather I want to analyze my practice of that to come up with the set of skills. But once I have those set of skills and ideally have started to work out which of those skills should be taught first versus last, and like which things are a little more fundamental and easier to start with and which things build on other things, once I have done that work, then the actual development of curriculum for modules that teach each of those individual skills is a huge amount of work also on its own. And in particular, I think it's a lot of work because if you want to teach a certain skill, like just understanding how the stack operates, you really, in my opinion, you want to build a tool that can help convey that information, because a lot of the knowledge that you're employing in order to hack something, in order to develop a exploit for a real vulnerability, both to understand the vulnerability as it exists and to develop the exploit to take advantage of that vulnerability, a lot of the skills that you're using are about understanding hidden concepts in the computer. Things that are not unknowable, certainly, but aren't obvious and are usually built in such a way to hide them even from the programmers that are working on these things. You can write a lot of stuff in C and have just like a base level understanding of how the stack works, know that there's like stack frames, and that's about all you need to know. Not really have to worry about how things are laid out within a stack frame, what the like sort of begin end structure is, how the calling mechanism works. A lot of details basically that are intentionally abstracted away from the developers. Julian, hey, how's it going, man? So I'm just sort of chatting. I've been going for, I don't know, about 40 minutes, just talking into nowhere, because, you know, I wanted to sort of chat about some ideas that I have, or really chat around the goal that I have of developing some like teaching hacking curriculum, and why I think my approach to teaching it would be different and ideally more effective, or at least more approachable. Let's say, I don't want to assume it's more effective, but might be more approachable than a lot of other curriculum around hacking. And so, you know, I figured I would come and do some sort of like chatting about that on the stream, but of course I don't have many people who view the stream, so mostly I've just been, or entirely I've just been monologuing about my thoughts, and maybe somebody will view it on a VOD at a later point. But if you want to hang out and you want to discuss with me, I'm happy to have somebody else to talk to about this. So what was I saying? Right, so if you want to show how the stack works in detail, it's rather useful to have a tool that can visualize the stack, for example. And not just a tool, not just a diagram in a blog post, which is obviously better than just having a textual description of it and hope that somebody can imagine it in their head in the way that you are when you are describing it through text. It's still better to have a diagram, I think, because this is, you know, fundamentally the stack and how memory gets laid out in particular with the stack, but also, you know, it also applies if you're talking about the organization of memory that's on the heap as well. It makes sense to have a diagram because there is a sort of a physical component to that. There's a limited space, and these things exist in particular places. And the fact that one thing is adjacent to another thing in terms of memory addresses is critical to how the exploiting of these things work, right? So the diagram is quite useful because it begins to convey that physicality and allows you to have a mental model that really does correspond to, you know, this essentially virtual physical structure that the memory has taken on. I realize virtual physical is kind of a oxymoron or whatever, but it's, I'm just not getting the right term, I guess. But obviously it is virtual, but at the same time, it has the characteristics of something that has a physical place and takes up space and can, you know, and you can put a thing at that place to change what was originally there or replace what was originally there. And those are qualities that come with concepts that have a physicality to them, I guess, is what I'm saying. Versus you might have the concept of like pieces of data that are addressed by their hash, for example, content-based addressing, essentially. And those pieces of data don't necessarily have a place that they exist at. They have a name and an address, so to speak, but that address isn't really organized in a way that is going to allow you to take one thing from one place and put it in another place, for example, because the place is the thing, so to speak. So there's definitely ways to design concepts around data that don't have that same physicality. But the fact that the stack does have that is critical to why you can use a buffer overflow to achieve an exploit. It's not the only thing that you need to understand in order to do that, but it is, without that being how the stack worked, then a buffer overflow wouldn't be possible, because you wouldn't be overflowing into other things, you would just be overflowing into nothingness or whatever, and then there's not really an overflow, so to speak. So that's why a diagram is useful, right? Because it is more correlated to what the concept is than a simple text description of the concept. Or at least, maybe it's not more correlated, but at least it adds onto that concept, or adds onto that explanation in a meaningful way. But I think there's something that's even more meaningful than having a diagram in your blog post about buffer overflows, showing the stack layout of an x86, function frame, like a stack frame and maybe multiple stack frames. What would be more useful is something that you can interact with. You have a way of calling a function and seeing what the stack frame then looks like, and then, basically a debugger kind of thing, and you can interact with and change what code is being run and how that pushes and pops things, and etc. Like, for me, having something that's interactive is what really provides the capacity, the core of how you can learn that thing. Because maybe you read the blog post, you still got to practice it in a real program in order to achieve what you want. And you're going to use a GDB, most likely, or, x86 debug, WinDebug, whatever, depending on your platform. But you're almost certainly going to use a debugger in order to get that introspection into what's going on in the real program when you're doing the practice. But you could also have that same introspection in the learning process, in my opinion, and get that earlier in the practicing, and help build that intuitive understanding of how it works, and do it separately from actually exploiting a buffer overflow, for example. So I'll get back to that, but Julian has a question. What I still don't understand good? How and when to use the proper gadgets. I mean, if I want to leak the puts libc, for example, use pop, RDI, GOT, PLT, and a return address. But I learned those mechanically, and I don't know how to adapt, for example, the program gives standard out leak or anything, or if the program gives standard out leak. I'm trying to determine if I understand as much as I think I'm understanding about what you're asking. So, yes, you can pop something into RDI. So, well, okay, let's start with, you said you've learned that sequence of 3 stack values, 2 addresses to return to, and 1 value that gets used from the pop. And then and a 4th one, that's the return address to something else. Do you understand why those are the gadgets to use? Why that is the thing to construct in the case of trying to get a libc leak using puts? Okay, cool. That's totally fine. So Julian says doesn't quite understand why that's what he needs to be doing in that case. Just sort of it works, right? And we've seen it presented in walkthroughs or otherwise tutorials or something, like here's how you can do it. And I think this is a perfect example of one of the things that I was mentioning before you were on the stream about how if your learning process is putting certain things sort of like the cart before the horse, so to speak, if you are approaching, okay, let me do a ROP challenge and achieve a shell or what, read a file or whatever the goal is using a ROP chain in this challenge, but you haven't necessarily learned some of these other fundamentals that are ultimately skills that are actually involved in completing that challenge, then you can end up with this very like spotty, perhaps, understanding, which is, this is not me bad mouthing you or anything. This is just, I've seen that in myself, right? And so why I was talking about it earlier on the stream is because if I'm developing a course for this, I want to really hone in on those scenarios that people can get into, because I don't think your situation is particularly like unusual, effectively, that you can actually accomplish hacking something, you can accomplish exploiting some binary level vulnerability, and not really understand why it worked, but you were able to do certain things to achieve it by applying techniques that you'd seen before, and maybe a certain amount of like trial and error kind of thing. And so being on the lookout for those scenarios that people can get into so that you can see, okay, we need to make sure that they understand this skill before we have them attempt to work on this kind of challenge that requires that skill or makes use of that skill, because it doesn't necessarily require you to really understand that skill. But if you do understand it better, then you're not in a position, hopefully, where you've done it and you don't quite understand why you did it. Granted, like my experience with teaching programming and us working very hard to avoid those scenarios, students will still end up in that scenario. It's just inevitable that you're going to be like, okay, I've done a thing and I don't know why that was the thing to have done, or I thought it didn't work that way, but apparently it did, that kind of thing. Like you'll get to that position anyways, right? So, but you can try to counteract it and reduce how often that happens. So yeah, couldn't find anything about gadgets on the internet and how to use them and when, because Pwn stuff is not that popular and understandable by everybody. And if someone knows Pwn, they're often at a very advanced level. I see what you're saying. Yeah, so, well, let's talk about I'm more than happy to take the time right now to try to help explain why that gadget works, right? So the number one thing to start with is to understand the calling convention. As an example, that gadget or that chain of gadgets would not work on Windows. Do you know why it wouldn't work on Windows? Well, okay. There is the fact that the GOT situation is an ELF specific thing, but let's say you use the same, like, I don't remember what it's called, but PE binaries necessarily have a similar structure for runtime dynamic linking. I'm pretty sure. Let's assume that they did. There's still, even if they had a GOT PLT thing that you could use in the exact same manner as you can with an ELF, or maybe imagine you're in a scenario where somehow you can run an ELF binary on Windows. Even still, that set of gadgets would not work on Windows. And I'm curious if you can think of why they wouldn't work. Go to there are different calling conventions, like on ARM, etc. Yeah, but there's also, like, just on x86, there's different calling conventions between Windows and Unix or System 5. The System 5 ABI defines a certain calling convention, I believe, for the x86 variant of, like, the x86 64 rather. I think they just used the thing that was defined by AMD, because when AMD developed the 64-bit extensions, AMD 64, whatever you want to call it, they did define a particular calling convention for functions, because they realized, like, if you look back at the history of x86, there's like several different calling conventions that C used for different scenarios, and that just gets complicated, and it just, like, there's reasons why there are multiple ones on the 32-bit version of x86, but if you could avoid it, it would be ideal, right? So then AMD was like, okay, let's just have the one. But also then Microsoft was like, well, we want to do it differently for, I'm not sure what reason, to be honest. Maybe it worked better for their kernel. It's hard to say from where I'm at why they have a different calling convention. Because on 64 bits, registers are, I assume you mean parameters are passed through registers, and 32 not. That is sort of it, but not exactly, because I am also thinking about 64-bit Windows. So 32-bit C call, or whatever it's called, standard call, the like normal C calling convention, C decal, I guess, does not use registers for the parameters. You are correct. It puts everything on the stack. Can you, yeah. And that actually comes from Microsoft's compiler. I think that they just sort of implicitly defined that convention by creating a compiler that worked that way. And that's back in the day when maybe there was less standardization. So if you wanted to write code that ran on Microsoft DOS, you had to use Microsoft's compiler, basically. You couldn't just get some other compiler and write code and compile it to work on DOS, because Microsoft's compiler is the only one that, for example, adhered to the calling convention that Microsoft decided upon. So, okay, that it's basically related, but the particular difference is that on x86 and, sorry, on 64-bit, Microsoft passes them in registers as well, but it uses RCX, RDX, R8, and R9. Versus System 5, using the AMD 64 ABI, it uses RDI, RSI, RDX, RCX. Like, it puts RDI, RSI first, and it switches RDX and RCX. So, if you pop into RDI and then call the puts function on a Microsoft, like in a binary running on Windows, it's not going to look into RDI for the parameter. So let's look at, let's see. So let's just do, let's do, let's make it a lot smaller. There's no reason. It's just an example. Then what do we need? Include string.h and do stir copy, stir n copy. And then So, how do we want to do this? How can I make it? I'm not sure I can write code that's going to force it to work and give me the pop RDI that we would actually use in the ROP chain. But let's assume that move RDI is actually pop RDI and something else had done push well, I guess move RDI into RSP is pretty darn close to pop. Oh, you know what? No, because I'm doing this as a local string. Can we do? Oops, my coding skills are excellent right now. And we'll just do local star equals string. Do 0. It's hard to get the exact same code that we would use from the gadgets, but what we are attempting to do is this, except instead of string, right, we are doing we are saying take the address of puts and treat it as though it's a character pointer. So it's treated as it's a string. Store that string pointer on the stack of whatever function we're currently in, and then call puts and pass the pointer that we stored on the stack into puts. So can we do 01? Is that going to be any better? It's too optimized at that point. So what we're trying to do is say take the address of puts and move it onto the stack. And so this bit of code is actually not a piece of code that we run from our ROP chain. It is implicit because the second piece of your ROP chain is that GOT entry, right? You've got pop RDI and then the GOT entry of puts, which is an address in memory that is equivalent to, or it will rather have the address of the real puts in it. So that part gets into another skill separate from what I'm talking about right now, which is how the global offset table PLT stubs work, which is about dynamic linking. So we could talk about that afterwards. But for right now, let's assume that GOT, wherever that is in memory, has an address in it, which is the address of the puts function in libc. And so we are doing the equivalent of these two instructions, I guess, by saying, like, take whatever that location is and put a pointer to it onto the stack. Now here it's putting it into RAX, into a register, because that's just what it's going to do. That's how the compiler decided to do it. But if we, instead of moving it into RAX, we had moved it onto the stack, then we could have popped it into RDI. And so this part is our pop RDI. And then after the GOT, because we're saying pop the thing from the stack, which happens to be the thing following RDI, then we can call puts. And that's why we have the PLT entry of puts. We're returning to the PLT entry for puts, or the PLT stub for puts, which is the equivalent to saying call puts. And so we have this C, like we have the equivalent of this C code, which will just print out the address of puts. And maybe I can actually run this. Oh, we need to say, and I guess I can, oops, take out the string parameter. We don't care about that anymore. Then I guess I can make this main. Okay, and then it prints out whatever this is, which is, it's binary basically, because the address of puts isn't guaranteed to be printable ASCII characters. But it has this, or, we could also present it like printf right, address of puts is this. It's only 4 characters on here because I don't know why it's only 4. I think it just, there must be a 0 byte there must be a null byte in the address of puts. And so it's just stopping there, because it's going to be 8 bytes total because we are on x64, but we could do 32-bit as well. Why doesn't it like that? What? This code should not be. I don't know. I don't know what's wrong there. That's very old GCC though as well, so maybe that's part of it. But let's say then we look at it on Windows. Where we go? x86 MSVC rather. Doesn't know about that option. That's fine. Oh, and we can't. Can we run it? I guess we can't run it if it's MSVC. That's fine. So MSVC is generating a lot more code just off the bat. But, this is the bit that we care about, really. And we are pushing, let's do x64. So we are putting it into RCX in this case. We're getting the address of puts somehow, and we're putting it into RCX and then calling printf. Oh no, because I've changed it, so it's not actually the equivalent anymore. So we just say puts. So yeah, we are again moving it into RCX, whatever this address is that we've stored on the stack. So the first thing to understand is that the pop RDI is because we need to set up the first parameter to the puts function. We're going to call the puts function. And in order to call the function, we need to set the parameters according to the calling convention of whatever system we are on. And so, since this was presumably on Linux, 64-bit Linux, then the right way to set the parameter to, or the way to do the first parameter for a function call is to put the value into the RDI register. And we could have said move RDI. So we could have said, like, I'm going to just do this in a comment. Move RDI some address. Right? And that would have put it into the RDI register and then call puts, for example. But there's some issues with this approach. One issue, like, okay, maybe first off, we would have to find a gadget that did this, that had this instruction, and that's not going to show up. So because we are constrained to doing ROP gadgets for our exploit, we have to find each piece of that set of code is either purely a piece of data or it's one or more instructions that we can find in a gadget. And this is not an instruction that we're going to find in a gadget, assuming this is the address of the puts function. Partly we're not going to find that because the code doesn't know what the address is until it's linked at runtime, because it's going to be randomly laid out in memory, right? We're dealing with ASLR, that's why we need to leak. So we don't know what the address is when the code was written, or when it was compiled, basically. So the code that has been compiled, the assembly instructions, won't have that address in them hard-coded in any way. Even though technically, if this happened to be the right address, we could get the equivalent behavior out of this piece of code. But that's just not ever going to be code that you'll find. And with ROP, you're always working with the code that you can find from the program already. And then secondly, the call to puts, you might be able to find that. You might be able to find a gadget that said call puts and then ret, for example. And you could just use that gadget. But you could also achieve it by saying return to the beginning of the puts function. And that's similar to the call. I guess it's actually, we need to do we need to not use the call approach. Is that true? Well, we could use the call approach if we then followed it with a ret. If there was a gadget that was like, so that's one gadget and this is another gadget, we could still do the call puts ret gadget. Because it would call puts, then it would, at the end of the puts function call, we would return to this instruction, which is the ret, so then we would return back to your next gadget. So that could work, but we probably just don't have this gadget. It seems unlikely because there's probably also, pop RB, pop RBP and etc. Other stuff that finishes up the function. Assuming that call puts was the last thing in your function, like you still end up with stuff like this, right? Because the compiler has its epilogue that it needs to create before it actually does the ret instruction. And maybe we don't want to deal with those things happening. So rather than say call puts, we can say address of PLT entry for puts. And when the ret from here happens, then it says, oh, we're going to return to the address of the PLT entry, which is the beginning of the puts function anyways. So it achieves the same intention as the puts call. And if we then have another location, when puts finishes, it's going to have a ret instruction because it's a normal function that's been compiled by the C compiler. So it'll ret and it'll use this entry. The next thing that we have in our chain, it will have as the ret to go to. Whatever, and so we can say call puts by using this as a ret value as the pointer to return to, and say after the puts call finishes, go do this other code by putting another instruction after it. So to break it down, we have pop RDI, address of GOT entry, and then Okay. Trying to think about whether this is as equivalent as I was making it out to be. So yeah, the local stir variable in this bit of C code is a character pointer, right? So the data that represents this variable is, in the case of a 64-bit system that you're compiling for, is an 8-byte pointer. And what it points to is the thing that we're going to print out. So we aren't actually printing out the address of puts. Yeah, maybe we need to do it this way. And then maybe maybe that's what the issue was. I don't know. It may not be possible to write it as write C code that is doing what I want it to be doing here. I'm not sure. I'm going to set that aside. But this is the value that we are going to pop into RDI when we run pop, because this is our stack. And these are like, so again, I'm going back to a diagram, right? Because almost always when you are dealing with stack related concerns, a diagram helps. This is just a really unfortunate diagram because I'm just doing it live in text. Let's do this with lower addresses and higher addresses up here, because that just fits how I've already written it. Okay. So this is our stack frame. Lower addresses are here, so when things are pushed, if we push another variable, like let's say we've got X and Y, and we have some code that says push Z, we'll get local variable Z up here, right? So we're clear on that aspect of how the stack is organized. Is that correct? Give me a yes or no if you're still following along or what. And let me know if this is actually not the question that you have, if this stuff is what you are already understanding and there's some other aspect that is the difficulty. Okay, cool. So one of the variables that's on the stack is going to be the buffer that we are overflowing, assuming that this is a very, standard overflow a buffer into the return pointer kind of scenario. But we just have NX enabled, so we can't write shellcode into that buffer. Or maybe the buffer is short enough that we can't write shellcode into it for whatever reason. So what we originally had is, let's do this, right? And then we've got, RBP I'm acting like I'm in my editor where I can just hit square bracket and it won't type a new one. And then okay, so this is what the stack frame looks like to begin with. We've got some local variables, whatever. We're not concerned about those because we can write the buffer, and when we write, it goes to higher addresses. So it goes this way, this direction. And crucially, right, the overflow is the vulnerability. That means that instead of finishing the buffer at this point, which is how I've tried to diagram the end of where the buffer is supposed to end, this is supposed to be the size of the buffer, and the code should not allow anything outside of here to be written when you're writing to the buffer. Well, it turns out there's the bug, whatever it is, that allows you to write past it. So you can overwrite this value, which is the value of the RBP parameter that is pushed at the beginning of the function. That is also, it's not exactly a calling convention, but it's standard stuff that is created by the C compiler. You can probably make a C compiler generate a function that doesn't have that little bit if you needed it to be like incredibly fast, and you weren't going to use RBP for any reason. You could do that, but setting that aside, if you're not optimizing it, for example, you will have a push RBP instruction generally as your first instruction in the function. So when the function starts executing, this is where RSP points. And then we say push RBP, or rather, sorry, this is where RSP points. And so when we say push RBP, it now points to here because it puts the value wherever the stack pointer currently points and then moves the stack pointer up, or in this case, sorry, down by 8 bytes, right? That is the behavior of doing the push instruction. So now that bit of data is there. That's fine. And then we have move RBP into move RSP into RBP. So now RBP and RSP point to here. And that's okay. That's, whatever. It doesn't actually change RSP at all because we didn't push anything or pop anything. But that's how we then use RBP minus whatever to refer to the variables on the stack. And then what we do is we subtract from RSP some amount and generally make it so that RSP points to here. And we'll later either add to RSP or call the leave instruction, which will ultimately pop this value back into RSP. I think I'm forgetting how the leave works, but the idea is when the function finishes, RSP ends up pointing back to here. So we'll get to that in a second, right? So RSP is pointing to the bottom in terms of addresses, the bottom of the frame, and RBP is pointing to the top of the frame, wherever the variables, they're basically, the difference between these two is the space where the local stack frame variables will be stored. And just after that is the pointer, or rather the previous value of RBP that was pushed. And just prior to that is the return address that the function will return to when it does the return instruction, when it does ret. This gets added onto the stack. There's no push for it, but when you have a call instruction, so at some point we did call main, basically. If we were to run this program, some bit of code would say call main, effectively. And the call instruction is what also does the push. So it does a few things. It moves the instruction pointer to the first instruction in that code, and then it also pushes the return address onto the stack. And then that's why RSP points here when we started the function. Okay, so that's the structure that we need. And because the first 4 arguments are passed, or maybe it's the first 6 arguments on Linux. So this would actually be argument 7 and 8. If you happen to have more than 6 arguments, then they still get pushed on the stack, the remainder. So we can assume that maybe we have some of those arguments. Fine. Basically, now, if we consider this structure, what we are attempting to achieve is control over this value, right? And we've seen, I mean, this part should be probably what you already understand, because we've talked about doing buffer overflow stuff before, and obviously you've done ROP stuff, so it does depend on having this knowledge, but I'm going to just try to go through it so that I'm building up towards the full explanation of the ROP chain that you've talked about. So we want to control what this is, and the way to achieve that, right, is we do our buffer overflow. And so that allows us, this is whatever we put, like however large this is basically that prefix, however you want to call it, value that generally we don't care what it is. We just fill up the buffer with some amount of data. And then at exactly the correct point, which in this case is the next, or rather, 8 bytes past the end of the buffer. So we can basically do, let's do it this way, all right? Okay, so we fill up the buffer with junk, and then we fill up the next 8 bytes with junk, because that's where RBP is pushed. And then at this exact point is where we put the address of pop RDI ret gadget. So somewhere up here, we have pop RDI ret, and then we also have .plt. I guess it's right, and we'll have like okay, so this is just other stuff in memory somewhere. It's obviously not necessarily laid out exactly like this, but somewhere in memory are these 2 instructions, pop RDI and ret. They don't even have to be actual instructions in the program. If you simply have a sequence of bytes that can be interpreted as pop RDI ret, which is I don't know. I think it's probably just 2 bytes, basically. Ret is like C3 or something. Yeah, C3 for ret. And then, oops. Not pop A. And then 8F. Or sorry, 5/8 plus, in the case of RDI, it's like plus 7, I think. So it's going to be 5, or sorry, no, 5F is going to be pop RDI. We could do, yeah. Oh, maybe to pop cannot encode 32-bit operand size. Yeah. Okay. So we would have like a 5F and then a C3. Oh, it just does one instruction, but yeah, pop RDI is 5F and then C3 is ret. So if we just have these 2 bytes anywhere in memory, then we have that particular gadget. So we can find those 2 bytes in memory, and we put the address of where they are in memory, assuming that's an address that we already know the base of because maybe it's not a PIE binary or it's leaked something within the binder itself, but just not libc. Fine. So we can have that address, and that's what we replace the return address with. So far, so good? Give me a yes if you're still following along. Or an F in, well, no, I guess F is for paying respects. Yeah, just a yeah. It's fine. Cool. Okay, so we figure out that address, right? You use ROP-Gadget or some tool, it's going to tell you an address that you can place here. Then we need something that will be popped into RDI. So we can, I'm going to set that aside for right now, and let's talk about how the function is going to work when it finishes when the function here actually leaves, or whatever this function happens to be, the vulnerable function. In this case, we actually don't end up doing anything with RDI, or sorry, RBP. So maybe I could have left that out. But it happens in a lot of code, so it's probably better to have that consideration. But the most important thing for what we need to be looking at is the fact that we have this sub RSP. And if you recall, after we did move RSP into RBP, then they both pointed here at the top of the set of variables for this stack frame. Then there was a sub instruction that subtracted however much space the stack frame required to store its variables. So whatever the length of this buffer is, plus all the other variables that we have. It's going to subtract that many bytes, and so RSP now points at the bottom of the stack frame. When we get to the end of the code for the function, so it's read in our buffer and maybe it's done some other stuff, whatever needs to happen, it's going to take the RSP and it's going to add the same amount of bytes back to it. So now we do add RSP, and RSP again points to this same location. as RBP is currently pointing to. And then what we do is we say pop RBP. It's not in this one because we have optimized it away. And I think if I do O0, it's going to give us a leave instruction, which does a similar thing, but yeah. So the leave instruction is sort of avoiding the need to do the sub or the add part. So in this case, we subtracted 16 to get RSP to the bottom of the frame. The leave instruction both adds back the same amount to RSP. It does that by just moving RBP into RSP. So if RSP points here, then when we say move RBP into RSP, they now both point here, right? And that's the first part of the leave instruction. Then the second part of the leave instruction says basically pop RSP, or sorry, pop RBP. So we pop a value from the stack. Although I guess maybe my... Oh, you know what? My explanation was wrong earlier. Sorry. See, even like my level of understanding is enough to do a lot of these things and be able to craft, workable ROP change and stuff. But even like the particulars of some of these things, still trip me up a little bit. So, RSP is actually pointing here. Or sorry, RBP is pointing here when the function runs. The reason that RBP is pointing here is because we did a push RBP, which like RBP points somewhere else, but when the function starts, RSP points here, we say push RBP. And so RSP now points here. No. I guess. When the function starts, RSP points here. Okay, that makes, yeah, okay. Sorry, see, and this is why, it's probably helpful for me to go through these explanatory things because I'm also operating on some level of like being confused about what's going on, but still knowing enough to be able to solve challenges and stuff. So when you call a function, we push like RSP points here, let's say, right? And then we push the return address. So RSP now points at that return address. Then we push RBP. So RSP is here. And then we say move RBP into RSP. So both RSP and RBP point here at the old value of RBP, the old base pointer. Then we do the subtract to establish sort of the stack frame section, which includes, in this case, it turns out, includes the RBP pointer that was saved. Then the function does its whole thing. We do our buffer overflow with the junk and putting our ROP chain, and we'll get to the other gadgets in a second. And then the function is going to exit, which will enable our ROP chain to run. So when it does the leave command, the first thing it does is say move the current value of RBP into RSP. So now we're back to RBP and RSP both point to here. And then the second part of leave says pop the top of the stack into RBP. So now we've popped we've popped into RBP, which means this value, which is junk at this point, but that's fine, gets moved into RBP. So it's pointing somewhere else in memory, somewhere, quite possibly an invalid, like a memory address that if you referenced it would cause a seg fault or something. So I'm not going to put it in this diagram, but it's pointing somewhere technically. And RSP now points back to here. So we've sort of undone all the steps that we did in the lead up to the function. RSP again points to the return address that was originally pushed by the call instruction. But we have overwritten it with our first gadget, right? Okay. So now when the ret instruction runs, it's going to pop this address into RIP, effectively. So RIP was pointing to this ret instruction, and now RIP is pointing here. And because we did a pop from the ret instruction, RSP now points to here. And okay. So with RSP pointing there, and RIP pointing at the beginning of our first gadget, which is pop RDI, well, that just says pop the value that RSP points to into RDI. So basically, RDI now points to this. And let me... Oops. Oh no. What have I done? Hit the wrong... Jesus Christ. And now RSP points here because we did a pop. So RDI is pointing at this location in memory, which has 8 bytes for an address of where puts actually exists. Wherever it ended up when it was loaded into memory at the random layout offset that was chosen by the kernel, etc. Whatever that actual address is, which is the value that we want to leak, RDI currently points to it. And RSP points at this location. And now RIP points at the ret. So when we ret, same thing as what happened on this line, RSP is going to take this value and pop it into RIP. Or sorry, not RSP isn't going to do that. The processor is going to take the address that RSP points to and pop it into RIP. And so this is address of puts at PLT. So that means after the ret, RSP is going to point to the next thing in memory after the address of puts PLT, and RIP is going to point here. Following so far? And again, I feel like you've been following along with everything, which also makes me feel like maybe what I'm explaining is not getting to the heart of what the confusion is on your part. And maybe it's not that you're confused with how this ROP chain works, but some other thing is the concern, and I'm not understanding it. But yeah. So at this point, our IP points at a call instruction. And the call instruction just says call whatever is at this location in memory. It's like a memory reference, so I guess I should put a square brackets around it. This is like keyword pointer. Okay, 50-50, so, I mean, that at least tells me that there's some... If it's all stuff that you understand, then yeah, I'm not actually helping, but I feel like if there's some stuff that you aren't getting fully, then maybe some stuff is helping, and that's better than nothing. So, and again, this really goes to the heart of why I think having like an interactive system that's basically a debugger, but much more simple than GDB and much more oriented at displaying the behavior, and you can step backwards and forwards as you use it. So, okay, we got here, but we want to go back one step and then see the difference as each step happens. Like, that would be pretty critical for a learning tool, I would think. And it's kind of annoying to do it with this by hand process. But if I wrote a program to do it, that would be much more meaningful, I'd say. That's me getting back on the topic of the curriculum development. But sorry for the tangent. So at this point, RIP is pointing at the call to the keyword pointer to puts at GOT. So whatever value is in this 8 bytes here, that is the address of puts, it's going to call that, which is effectively the same as saying call puts. It's just there is a indirection here because we don't actually know how to say call puts in the literal code. We couldn't have put the absolute address of puts because there's no place that it absolutely will exist, right? Because of the ASLR thing, it's dynamically loaded. Not even just ASLR, but because it's a dynamically linked in library, it may or may not be at any given place in memory. ASLR just guarantees that the pieces are more randomly laid out in memory. But even before that, you would have this structure. And so we have the address of puts, the actual beginning of the puts function, which, you know, would be like puts, I don't know, stuff. I don't know what's in the puts function, right? But we got a bunch of stuff, right? So this, whatever memory address this is, or really this first stuff instruction, is going to be here. And so when we say call keyword pointer puts at GOT, we say take the value that is at puts at GOT right here. Take that value and make that the thing we're calling. So take this address that is the address of this and call to that. So we call to the beginning of the puts function. Well, the puts function takes a parameter, right? So it's going to look for okay, that's fine. Yeah. So I mean, basically at this point, the puts function runs and it uses whatever RDI is as a pointer to the string to print. Well, RDI points at the address of puts. So it basically treats those 8 bytes as though they were a string and tries to print it to standard out. And then when that finishes, it does a ret instruction. It has a ret here. And that ret then pops this address. It does the same thing as before. So RSP ends up pointing back here. It does a pop. And that pop pops this into RIP. So we run whatever the next bit of code is. So that's what that 3 set of gadgets is. To achieve a leak. And the key pieces of information that we need to accomplish that are, we need to be able to figure out what the address of this pop RDI gadget is. We need to be able to figure out what the address of the GOT and the PLT are. Oops. If we can't figure out those addresses, because maybe ASLR is turned on, it's a PIE binary, and there is no leak, then this approach won't work for us. We would need to do something else to achieve a leak, or yeah, I'm not really sure how we would go about it if we couldn't leak anything. I'm trying to remember what we did on the last binary. I think it was just that there was no PIE, so then we didn't need the leak. Because there wasn't a leak in this challenge. So, yeah. Oops. The wrong spot. So, to summarize, this behavior, like doing a ROP chain, is relatively advanced sort of vulnerability development work. And I say that because it depends on several skills. It depends on understanding the organization of the stack, how a stack frame is structured, at least one that is compiled by C code. I mean, the core of like doing the ret and having that be where RSP points after the call instruction, that's defined by, in this case, the x86 like architecture definition, basically. You know, what that ret instruction, or what that call instruction does. But the stuff with like push RBP and move RSP down here and stuff, all of that is really more the convention of the C compiler, and it may or may not be followed. It's definitely one of these things that's like sort of encouraged or otherwise presented as a fundamental pattern to use by Intel or by the x86 sort of design, and probably is a similar pattern with ARM and other architectures. Just this general concept of how to set up a stack frame and how to use one register as the base and then the other register as the top of the stack frame, to sort of dynamically size your stack frame and use one of them or both of them as offsets for calculating the address of the variables within the stack frame. But so understanding those pieces is critical. Also understanding the behavior of the ret instruction and how it's going to pop a value off of the stack and put that into RIP, and crucially what that means about now, like after our first ret, RSP now is pointing at the second piece of our ROP chain, which in this case, this second element in our ROP chain is not an address to return to. It is an address, it is just a piece of data that we want to pop into the RDI register, because the pop RDI is going to take from wherever the stack is pointing, and because of the behavior of the ret instruction, RSP is pointing at this location, which happens to be the second entry, the second set of 8 bytes in our ROP chain. And so, okay, now RSP is going to pop, or the instruction is going to pop from this location and put it into RDI. It happens that what we want to pop into RDI is also an address, but it's actually not an address of code. This is puts at GOT is not a piece of code. It is like a table of pointers, basically. It's like, if I say like, void pointer GOT 10 is something like this. This piece of data is located in memory. In this case, I have it as 10. We could put it as 3 because I've only put 3 entries in there. But each of these is a void pointer with some value, effectively. Sure, we could cast it to be a void pointer. Right, and the table just has the addresses of either the next entry, the next instruction, it's like move EAX, or maybe RAX. I don't remember exactly what it looks like, but it like the address starts off pointing to here, but then when we jump to this code, it goes back and it puts the real address into here, basically. So that's all. That's all a different piece of knowledge that is also necessary to understand why this gadget works how it does. But to begin with, just knowing what pop RDI does requires us to understand the stack, to understand why we are even doing a ROP chain, how we got in this situation in the first place, and to understand the behavior of the ret instruction to know that the second piece of data in our ROP chain is the thing that is the piece of data, the 8 bytes that will get popped into the RDI register, whatever they are. Maybe you need to pop the number 72 in that register for something to work properly in your exploit. Maybe, it's not an address of GOT, but in the case that is presented with the leak approach, we want it to be the address of the GOT entry, whatever that one is. And so, yeah, so those are 2 pieces of knowledge that are critical. And then the third piece of knowledge that is critical for how this works is really how the PLT, the procedure linkage table, is structured, the little chunks of code, as well as how the GOT table, the global offset table, is structured, and how they interact and what that is used for in the case of sort of runtime, lazy, dynamic linking, that whole behavior. So having understanding of a linker and the behavior of how a linker works and how people have come up with the mechanism by which to do this runtime linking is necessary in order to be able to fully understand what's going on when you use this leak ROP chain. So that's why it's a fairly advanced technique, because it simply builds on top of several of these different pieces of information. And we didn't even get into the fact that you have to understand enough of the assembly code to know what it means to say pop RDI. What is RDI? What are all these other registers that I've been talking about? RBP, RSP, RIP, etc. So there's that fundamental piece of knowledge as well that sort of underlies. You don't necessarily need it to understand the stack, but it's helpful to have the context of understanding the instructions that are running in order to be able to understand what the stack is doing and the details of how it is structured. So all of that sort of goes back to what I was talking about with the course development plan, which is, basically, I would not start anywhere near any of this stuff. I would not want my students to get into a position of understanding that you can use this 3 or 4 instruction ROP chain, or 3 or 4 element ROP chain, I guess, in order to leak an address from libc and then calculate the base of libc in order to do other ROP chain stuff that is using gadgets from within libc. I would not want them to get to the position of knowing that you can use that without understanding the why that works. And it's really difficult to avoid that by saying, okay, well, all you have to do is understand all the details of how linking works and dynamic linking, and understand all these details about the stack and the particulars of the x86 instruction set. I say it's difficult to go that route because that takes a lot of time to build up that knowledge, because there's a lot of details in there, and those details are necessary for the purpose of having a real world machine that does what you need it to do, be able to run code very quickly, and that does, that works how people write actual operating systems and stuff. Like the design of all of these pieces that you need to learn, it was not designed for people to be able to easily learn it. It was designed to be as functional as possible, and with the acceptance that, relatively few people are going to put in the time to understand the details of it. But fundamentally, not everybody needs to understand the details, except unless you're trying to hack this stuff. So my approach would be to say, okay, we're not going to teach all of these concepts within the context of a real computer and the details of the real mechanisms used by x86 binaries on Linux or Windows or whatever. Not because that's not useful. Obviously, that's where you want to end up, or learn it for ARM or whatever. But, being able to apply these skills on real world systems is fundamentally a good end goal to have. But it's not necessarily the ideal way to learn the concepts. It would be better to learn the same fundamentals of things like how a stack frame works and what the instructions are and how they operate in a much more simplified, learning-oriented computer system that was perhaps designed specifically to be able to expose these ideas and still have them, still have exploits that work on the same principles. So then the principles of how these things work, and then when you want to apply it to x86, you're more learning, okay, here's how the x86 world achieves that same principle. But you know what the goals are, you know what the structure and the process is, so learning those details comes in a context that makes it a lot smoother of a process to learn. That is my, conjecture or whatever, and what I think is the way to teach hacking is basically don't start with a real system and say, okay, here's a binary, here's the assembly for it, or here's the assembly and the source code for it, fire up GDB, and we're going to get into writing something to exploit that. I think that is going to, more often than not, I could have been in Vim mode. Nice. That is more often than not going to end up with folks who have learned certain techniques that have worked And so they can apply those techniques, but they don't have the more fundamental understanding for why those techniques work and how to reorganize them and take a piece from here and a piece from there and suit, tailor stuff to a particular situation. Because I think when Julian gets back, he could probably concur with this. When you start going through and you have to do a bunch of these ROP challenges, like, they all have some particular thing that makes them a slightly custom scenario that you have to deal with. And then you're really dependent on, if you understand the fundamentals, then you can take the, standard technique and modify it and otherwise like build on it in order to accomplish the ROP chain that you need or whatever the exploit is. But if you don't understand the fundamentals and you just understand, I have these set of techniques to use, and your only options are like, okay, well, I can try this technique, or I can combine this technique and that technique, and maybe one of these combinations will work. More often than not, probably you are going to be in a situation where you don't have the tools that you need to solve the challenge. So I think a lot of hacking education, because there's so much that needs to be taught to then have the fundamentals in place, just sort of skips out on trying to teach the fundamentals. Maybe the author just sort of hopes, well, somebody will, try to learn this once they already know assembly code well enough, and once they already know details about the stack and all that well enough, that my cursory explanation of how we are exploiting stuff using stack related, behavior will work for them, right? You're just sort of like punting on trying to have all of those details in place. And just like, I don't know, if somebody is already at a place where they are ready to learn that stuff because they've done enough practice to have gained the knowledge through osmosis, or they have simply taken the time to sit down and like try to study assembly code, try to do a lot of reversing or something, then, hopefully they'll be ready and they can make use of that tool. But I want to build a system, or a curriculum, I guess, rather, that really is trying its hardest to start from scratch and go up from there, and teach all of the concepts that you need from assembly up through the details that eventually you would be able to then translate into how x86 works or ARM works or something. And that's a huge challenge. I get why other folks, generally speaking, haven't approached it that way, because it's just so much work. But I think it's worth trying, and I just think it's an interesting challenge to try to design custom sort of computer scenarios, custom machines that are hackable without necessarily being as complicated. Like, when I say I want to teach assembly language, I don't necessarily mean an assembly language that is anywhere near as complicated as x86. You could definitely design a computer that's like a stack-based computer that doesn't have a move instruction, maybe, that just has push and pop and doesn't work with fixed byte size, like, oh, you can push it 8 bytes, or you can pop 8 bytes, or you can reference, the low 4 bytes of some value, that kind of thing. Like all the complications that come into play with x86, and similarly with other real world architectures, you can, design a system that is maybe like a .NET CLR or the JVM or something that's still stack based, and you could probably design it to be exploitable in a certain way. And maybe, I don't know, I haven't really thought about it, but presumably .NET and the JVM have their own means by which they could be exploited to achieve, well, I don't know if you could do these stack-based attacks, because I don't know if they're actually allocating anything but scalar values on the stack, and certainly their like code base could be as much as possible written to avoid any of those memory corruption potentials. But assuming that your goal wasn't to avoid memory corruption vulnerabilities, you could design a similar system to one of those languages and have it be exploitable, and use something like that that's much simpler as the basis to teach the techniques and the fundamentals. And then once those fundamentals are in place and have become, more solidified in the student's mind, then you go on to the more real world categories or scenarios rather, and then try to build that. So you're separating out the complications of the real world, which maybe aren't that necessary for actually being able to understand these techniques, and you're separating those out from the fundamentals of the techniques. So that's the like broad scope of how I would try to design a hacking curriculum. And it's really, I got to think about what design I would use for a fake computer that is hackable. And maybe it would be a sequence of computers that get more complicated as we go, because even a stack-based kind of exploit is not necessarily the simplest exploit you could achieve. And so I still need to think a lot about what is the simplest kind of exploit you could achieve, in terms of, here's a program that takes input and is vulnerable to a certain kind of input, certain category of input can cause it to act in a manner that it was not intended to, right? And we can take that as the broad definition of a vulnerable program. And then maybe over time, we narrow that definition into one where the program takes an input that can include some executable code in it, right? So that's then like got a shell code kind of situation. But maybe, again, we could design the language that the shell code is not anything as complicated as real assembly. It could be very simple instructions, but you're still eventually exploiting a mechanism that results in your instructions getting run rather than the ones in the program itself. So you've got the same techniques, you're just not being hindered by now needing to understand how shellcode works, or alternatively just being given a blob of, essentially binary gibberish from your perspective and being told, and then now it does your exploit for you. Like, I also don't think that is the ideal approach either, is to like say, well, we're going to show you how to trigger an exploit, but then, don't worry about understanding the payload of the exploit, basically. So I don't know, that's what I think about surprisingly often, is how can I design a machine that is most optimal for learning about how to do vulnerability analysis and exploitation development for essentially compiled programs. Yeah, because I don't want to call it like binary exploitation. It has a similar theme to it, but I don't want it to be that complicated. And I could definitely see a way of integrating elements of exploiting code that is not necessarily, represented as compiled like assembly, whatever whether it be like high level assembly for, you know, a CLR or a JVM or something, or low level assembly. You could instead have it be an even higher level language maybe, and there's a different way of exploiting it. But on some, you probably need something equivalent-ish to unstructured programming, which assembly code is, right? It's just the sequence of instructions with go-to equivalents for control flow stuff. So when you're thinking about, you know, programming in terms of the unstructured programming paradigm, or, you know, just, yeah, I guess unstructured is the right term. What languages could you design that are still considered unstructured programming, so they have these mechanics and they work with a stack, but are still as high level as you could get in terms of the semantics and what details you need to understand in order to be able to follow along with the instructions? Because I think effectively the lack of structure in assembly is not what makes it complicated. It adds some level of complication, because when you then have, you know, the result of structured code has this like control flow behavior that is a little harder to figure out just from a linear sequence of instructions. But most of the complication with like x86 is really the details of all these instructions. There's so many of them, the details of how the registers work and all of that stuff. And we could just throw all of that out and not even worry about that stuff for now. And maybe if we want to teach registers, we could add registers in a different kind of machine later on. But once you've already understand the stack stuff, and now you just need to understand how, you know, a register-based machine works, right? And like maybe that's how they teach low-level stuff for like computer engineering curriculums, where, you know, understanding the details of how a machine operates, how an actual real-world processor operates, is part of the curriculum. Maybe they have these sort of learning machines. Certainly they have like MIPS and other simpler instruction sets, because a lot of times you might need to implement an emulator for it, or even maybe a physical, very small version of it. And, you know, asking somebody for a project to implement an emulator for x86 would be an absurd thing to do, especially for a school project. But maybe MIPS is simple enough where that's a reasonable, you know, major project for the quarter or something. I don't know how it works at university, but so I think I would look to curriculum for computer engineering, because this comes back to, I guess, something that I very briefly mentioned at the beginning of the stream, is my philosophy around hacking and how it relates to programming, which is that they are really deeply paired things. In my opinion, anybody that wants to be a good programmer would do well to learn about hacking, and vice versa. If you want to be a good hacker, I think this kind of hacking, there's other varieties of hacking, especially web-based stuff, which has different concerns and all that. But if you want to learn, you know, especially binary exploitation, learning programming fundamentals, not necessarily software development, but the details of programming and how software is created and why stuff is going to work the way that it does, and maybe computer engineering skills and that level of detail is going to be so helpful, right? So don't necessarily learn all of these details just from the standpoint of, I want to know this so that I can hack something. You should also try to learn it from the standpoint of, I want to know this so that I could build something with it, right? Building is the software creation or the programming side of things. Hacking is the destroying, breaking down something. But building something and breaking something are naturally related concepts. It would be very difficult to break something if you didn't understand how it was built. Like, how would you break the sun? You know, I don't know. There are people out there that would know how, right? But those are like astrophysicists, people that have the knowledge of how the sun came to be. And I'm talking in like almost mystical terms at this point, like the sun is some like magical thing, but just like, it's a giant ongoing series of nuclear fission explosions, or fusion rather. It's a vast explodey ball with a core of something or other in there. I don't know. It depends on the size of the star, right? But all these details, and how would you do something that would impact it to cause it to break, to maybe go supernova or just otherwise like implode on itself or something, right? How would you put out the sun? You're not going to know how to do that unless you understand how the sun works, how it exists, how it came to be. So in a similar vein, if you don't understand how a program works and how a program has been built, you're going to have a much harder time understanding how to break it. And similarly, in the reverse, if you want to build something that doesn't break, it really helps to understand how it could be broken. It's like that TV show that was popular in the United States. I don't think it's around anymore, and I don't know how much it got outside of the US, but it was called like It Takes a Thief. And it was like, somebody breaking into your house and then explaining to you, here's how I broke in, here's the things that you need to do in order to protect your home from real, malicious thieves breaking in. I'm doing this for a TV show and all that, but if you don't follow these instructions, somebody could actually break into your home and take your stuff. Well, knowing how to do that does require knowing how to protect from that does require the knowledge of how to break that. I mean, this is the part that's probably most obvious to anybody interested in InfoSec. Is like, if only software developers understood these vulnerabilities better, they would stop creating them, basically. And there's a lot of truth to that. I mean, there's also a lot of other concerns that come into play when you develop software that might prevent you from making those making the right choices from the security standpoint, even though you are cognizant of what those vulnerabilities are or could be. But if you're not even cognizant of what the vulnerabilities potential is, then it's going to be very unlikely that you just happen to build a program that has no vulnerabilities to it, basically, or at least any meaningful size program. So I see, basically, if you're going to hack on this category of hacking, you want to also be a programmer. And if you want to program stuff, it would be great if you were also a hacker, so to speak. So my curriculum really would ideally involve teaching both of those skills side by side. You build something and then you break the thing that you built. Or you break something that somebody else made and then you build that thing and try to build it in a way that is no longer breakable. So you're not just getting one half of the process, because I do think you miss out. It's a lot like how current software development instruction, and this includes the boot camp that I worked at, really focuses on creating more software. The actual programming and the overall process of software development, which includes a lot of other skills like design, project management stuff, process related things, architectural decisions for team oriented, development stuff, like not just the writing of the code, right? There's a lot of other stuff that comes into play with software development. So we focused a lot on that, on how to teach the skills to create software, because if you think, oh, I'm a software developer, then my job is to create software. But we didn't spend all that much time on the skill of reading existing code and being able to take a giant code base and figure out what's going on in it and fix a small piece of it. And that is actually a huge part of your job as a software developer. You may be tasked with like, okay, now you're part of the team that's responsible for this, 3 million line program. And here's a list of bugs. You got to go fix these bugs. Well, you need to be able to start doing what I call like code spelunking, which is like, let's go in and figure out how this project is broadly structured, and then I can search through the structure to find the piece that seems to be related to the thing that the bug is doing, and then, how can I read this code and use debugging techniques and stuff in order to better understand it so that I can eventually come to the level of understanding required to know what the bug is and how to fix it. And then I can switch back to the mode of creating software for the actual process of fixing the bug. So basically, in the same way that a lot of programming education leaves out one half of what it is to do software development, I think hacking education leaves out one half of what it is to do hacking. And again, this kind of hacking, which is software creation, or, well, let's just say programming. Because you don't necessarily have to do software development in order to know the programming that is the other half of hacking. But yeah, basically, if you write a ROP chain, that is programming. You're just programming a weird machine rather than programming C code. But you are creating a program because you need to understand it and think about it in terms of what those instructions are. Hey Foon, how's it going, man? I've just been just talking this whole time. A lot of talking. Went through a small explanation of a small ROP chain, basically, and just sort of going over my ideas for how I would do a sort of teaching hacking curriculum effectively. Glad it's all going good for you, man. Yeah, it's going well over here. Been working on some software projects, and they continue to be very fun and interesting to work on. I guess fun and interesting is the right way to put it. I mean, it's challenging work, and that's what I enjoy when I'm doing a programming task, is something that sort of is pushing me to understand more stuff. So I don't know. I feel like I'm probably have rambled as much as I can about my ideas on programming challenges or whatever. See, I'm at the point of rambling where I'm not even saying sentences that are what I'm intending to say. I've been just sort of going on about like hacking education and how I think a curriculum should be structured, and effectively, trying to get around to this idea of like, what should I be working on in order to build the curriculum around teaching hacking that I want to have exist. That's a difficult one. I'm not necessarily like an expert at curriculum development, so I don't know if just working on the like hypothetical machine that is designed to be exploited but be simple enough to understand without all the details of x86 and stuff. I don't know if just making that is the right way to go or what. I think I need to do a lot more reading. So like before the stream started, I was going through a bunch of these resources on topics that I have been influential to me In particular, there's this concept of weird machines. So, like, the concept of weird machine is a theoretical framework to understand the existence of exploits for security vulnerabilities. And I mean, I guess fundamentally it is a theoretical way of, like, a abstract way of understanding how exploitation of software even works in general. And I'm not necessarily of the right mindset to get into the deep theoretical aspects of it, but like the basic understanding of the theory is something that has really resonated with me ever since I watched a video where somebody was talking about it. I think it was the Sergey Bradis guy who sort of coined the term. I think he did a talk at DEF CON or CCC 3 or whatever, or was it CCCC? CCC? I don't know. Chaos Computer Club, their annual conference. And just this idea that, like, all these programs contain within them that are vulnerable in some way to basically an RCE, is how you might categorize the vulnerability. They contain some mechanism by which they accept as input a sequence, an input that includes within it effectively instructions to program that program, to treat that program as a machine, and the input that you give to it is actually the code to run that machine. So in the case of a very simple buffer overflow that allows doing, like, executing code on the shell, or on the stack rather, you can input your shell code. The program for this weird machine is just some sequence of arbitrary bytes, doesn't matter, and then some sequence of x86 instructions in the case of an x86 binary. So it's actually very similar to a real x86 computer, basically. Or it's some sequence of arbitrary bytes. Then let's say we're talking 64-bit, then it's 8 bytes of an address that needs to be an address back to somewhere in your buffer, and then at that location in the buffer is a sequence of x86 instructions. So it's not quite as simple as what I was saying at first, but part of the input is actually instructions to the CPU, right? And so the program unintentionally has accepted a form of input that includes effectively any program that could run on an x86 computer, so to speak. I don't think I'm explaining it very well. Food says hacking curriculum as in teaching people hacking. Yeah, basically. I think, one thing that I could do is try to do like a one-on-one kind of teaching thing, and sort of tutor people on the skill of hacking, but that's really it doesn't scale very well, and I think it would be difficult for me to find somebody who would be open to that and willing to compensate me for the time. I'm sure that I could find people who would be open to it for free, but I don't know that I necessarily have the capacity to do that for free. Tutoring is actually quite a lot of work to do well. I could sit down with somebody and not have anything prepared, and we could just hang out for a little while, and I could try to explain stuff off the cuff, but I think I would want to, have a somewhat more, I would just want to put more effort into it than that, basically, and I think then that starts to get into a scenario where it's really, I would need compensation given the amount of time and effort that would be involved. So what I'm thinking about instead is like, what I would do is put the time and effort into the development of a curriculum that you could follow on your own that is really organized around challenges, where if you can complete these challenges, then there's a strong chance that you understand the material well enough to then proceed to the next section, basically. And I mean, you know, that concept itself with the challenges is not novel in any way, right? But it's more what would make what I am interested in with my ideas of the curriculum design is really about what elements are we teaching, what order are we teaching them in, and how can we develop an environment and a set of challenges that minimize all distractions from the core thing that would be taught. And yeah, like if you try to teach a lot of stuff in hacking, there's so many other skills that are either required or at least are involved in actually accomplishing that, you know, hacking task or whatever, right? And so it makes just going to the real thing a difficult learning experience, because if you need to know 5 different concepts all to begin with, yeah, it's probably also hard to make it not boring. I mean, that's the thing with a self-directed curriculum. If it's boring to people, then they can just not do it. Like, I don't know that I mean, there's some level of could I make it more exciting or not, in terms of presentation and stuff, but there's also a level of like, maybe this is not a thing that you actually enjoy as much as you were hoping that you would, or you just thought, you know, I'll give it a shot and we'll find out. But like, it's not necessarily the thing that everybody wants to do, even though it may, like, that's one of the things, right? If you watch a lot of media about hacking or whatever, and you watch Mr. Robot, and it seems like a really cool thing to be able to do to like take over computers. Like, there's definitely a lot of people who are like, I want to get into hacking, but then it turns out like the particular process of actually doing the hacking is an incredibly, like, I don't want to say, well, incredibly is a pretty strong word, but it's a sort of solo, in your own head, mental, you know, activity that just requires a deep amount of focus and an ability to understand a lot of really detailed abstract concepts and put them together. And that's not necessarily everybody's strong suit or what is enjoyable to everybody. And so, yeah, passion plays a large role as well. I mean, if you find it fun, then I would like the curriculum to be as frictionless as possible for you to continue down that pathway of doing the stuff that you find fun. But if you don't find it fun, I don't know that I can design a curriculum that's going to make it fun for you, right? That being said, that might just me, there's a certain degree of that being me, like, you know, giving up on that idea or abdicating some responsibility for making it more fun than it, like, what am I trying to say? There's some amount of wiggle room in all of this, right? So there's some space of ways that I could design the curriculum, and I could make it really not fun, even for, you know, or make it really boring, even for people that are interested. or I could make it fun for people that are interested, but I can't necessarily make it fun for everybody, because there is also this overlap of you might just not be the right person for this thing, and that's totally fine. I'd say, I mean, I think there's stuff that I, have tried that I thought was going to be interesting to me and turns out not to be as interesting, and then you just don't spend your time on that thing or whatever. But at the same time, yeah, there's definitely room for me to make it more fun than the minimum amount of fun and interesting it could be, if that makes sense. And so I have to think about that. Because I think my natural implication, or my natural instinct, is to not focus very much on the I don't know how to phrase it, but just like, I guess some of the things that could make it more fun beyond the just inherent fun of solving the puzzle and feeling like you understand the thing, right? Like if you make a game, and I'd say curriculum and a game have a lot in common, because any video game has to involve in some manner teaching you how to play that game, unless it's, there's scenarios where maybe you already know everything about playing the game, but most games you're going to learn something about that game and how to play it as you go through. On one side, you can have games that are so Spartan in terms of reward elements, let's say. We'll get back to that in a second. But you can have something that basically has none of that, and so all of the enjoyment is the learning itself. But most games tend to opt for, you get some nice benefit, and I'm being intentionally vague here because there's just a lot of ways that you can have that happen, but you get something for having accomplished the learning and having accomplished practicing to the point of being good at the game, right? Like a very common thing is you have a story and you have a sequence of challenges that rise up to this, ultimate challenge result that takes into account all the skills that you've learned before and requires that you've practiced enough to be good at employing all of those skills. And so there, even just that structure, but also the context and the aesthetics and all the I don't know, like you take Dark Souls, right, as an example. The last boss that you beat is going to be, and I haven't actually played any of the Dark Souls games, so I can't speak to the specifics, but I've watched enough, people talk about it or otherwise like play it on streams, to get it enough to talk about it at this level, right? But when you beat that final boss, it's a much different. Yeah, they're very hard, and that's part of why I don't play them. That's not the place where I want to put my energy. I tend to focus more on puzzle games these days for whatever reason. But like when you beat that last boss, it's not just one more challenge that has no context, right? It's a thing that you've been leading up to through all the other bosses that you've beaten, through the story as minimal as it is in those games. I guess it's probably a lot more in something like Sekiro or Bloodborne, but it sounds like the actual Dark Souls games are much more minimal on the actual storytelling element. But there's other games where, I guess if you think about Zelda or whatever, right, when you beat Ganon whatever, there's all of this context as to why it's important for you to beat that guy, and you just know that's a strong representation of you having won the game, you having accomplished that stuff, right? So having accomplished potentially what is the ultimate goal as far as, you know, the core of the game. So all of those things are ways to make it more fun to have learned and practiced and gotten good at the game. Because you absolutely could take a version of Zelda that, or actually let's just use Dark Souls again, right? You could take a version of Dark Souls that is like the same first boss, and you just beat that same boss over and over and over again for as long as you want with no end. And that is a way to practice that thing, and you could get really good at whatever skills you needed to defeat that boss, but it's not going to have the same enjoyment because it lacks any structure and it lacks any feeling of ultimate accomplishment, and it just, yeah. But you know, these are relatively obvious things, even if they're not necessarily explicitly in a lot of people's minds. But if you play games, right, it's pretty obvious how the structure of the games plays a role into why it becomes fun to learn and practice the game. Even though it's not technically necessary, you could simply have the challenge, and then somebody could go through the challenge and do it as long as they wanted to practice, which is perhaps closer to what people do when it comes to things that are practice that are seen more as art or work. Like, if you want to be good at an instrument, you're going to practice a lot of boring stuff with that instrument probably. And, you know, not only boring stuff, but they talk about like practicing your scales or whatever with I don't know, piano. I'm also terrible at instruments. Or by terrible I mean I just don't have any experience, right? But you probably practice some very standard kind of beats and drum lines or whatever if you're learning the drums, and you know, you might practice those a lot just to make sure that you are keeping your skills up. And you're willing to do that because you know the value of that within the context of then playing a much more interesting piece and something that has a more inherent fun just in doing the thing, right? So that, there are also skills that the learning aspect of it is just has this inherent enjoyment to it, where, you know, maybe you just really enjoy playing the drums and you don't need to go play on a stage in front of people and have the external reward of all of these folks being out there to see you and cheer for you and you know, maybe get paid really well or whatever if you're in a popular band or something, right? Maybe you could just play in your basement and you know, you can enjoy it that way, in the same way that, you know, the folks that play in the band probably also certainly just enjoy the playing of the instruments on their own, but they, you know, they on some level also want those additional external benefits from doing so in the public arena and stuff. I mean, ideally I would make it free, whatever the thing that I'm working on is. It's weird how, like, for a one-on-one kind of thing, I would feel a need to be compensated for it. But on trying to make something to just allow any, you know, as many people as want to use it have access to it, I would probably want to make that free, or in some way try to make it as affordable as possible. Yeah, because I want people to learn this stuff, right? So, especially since they're not explicitly taking up my time in order to do the curriculum on their own, it would be asking for compensation for the development process, and that can be amortized across all the people that might end up paying for it. So it could, ideally, it could be a relatively minor, like, I don't know, but I would try to make it as cheap as possible, basically. And I do think that making it in the context of a game would be my ideal. Just because I really enjoy video games, and I think they're a good way to keep people's interest. It's just I also understand that they're so much work to develop, and just building the curriculum itself would be a lot of work. And yeah, I don't, it's one of those, like, maybe if I have the curriculum then and understand it well enough, I can then try to morph it or fit it into the context of a game in some manner. But that's, it's certainly something I've thought about a lot. It's just pipe dream kind of stuff. Or do that with a team of people. And that's its own set of hurdles. I have not yet. I've got the videos sort of on my YouTube queue, but I have not been watching a whole lot of YouTube, and like that's one of those ones that I would want to invest a lot of mental energy in like watching and really paying a lot of attention to what he's talking about, because I have a lot of respect for him, and I also like games, and I'm really excited that he's working on a game. Like that's really cool to me. So I didn't realize it was even a hacking game. Unless that's, I think I'm reading that statement right, because he's done streams where he's gone through some game hacking stuff. But I think the last 3 streams of his, like the last couple weeks, he's been working on a game and not streams, but like in making videos about it. But I hadn't watched them, so I didn't realize that was a game about hacking, in which case I'll absolutely need to go watch those, because that's obviously very similar to ideas that I've had basically. And my guess would be that I would have some difference of opinion on how to arrive at that, or how to achieve a hacking game, because I've had similar differences of opinion on existing games that are also hacking games, let's say. But I'd certainly be very interested to see what he did, or is doing rather. So I'll check that out after the stream for sure. Yeah, I don't know. This one just turned into me just sort of talking a lot around this idea. The reality is it's something that I've thought about for quite some time, and I need to start putting in the effort to do the thing. It's difficult because I have vague ideas of what I would want the thing to be, but not enough information right now to even really understand where to start from, or to know what parts of it are the things that I should start on, I guess is a better way to say it. My best bet right now is this, like, just the idea of building a very small machine, so to speak, virtual machine, and build it in a way that allows for vulnerable programs to be created with it, and see if I can make as simple and understandable a version of that virtual machine as possible. And then build like a sort of debugger tool for it, so that you can see what's going on when you are interacting with the machine and trying to program it, and then combine the programming and the hacking education together for that very simple virtual machine. But yeah, I've actually never built a real virtual machine, I guess. So that's, a piece that I need to just actually do before I can get towards making one that is useful for this particular purpose. Yeah, the debugger thing would be cool. Yeah, that's a fundamental or a very core part of like my concepts for what makes a good curriculum, right? Is being able to see the impacts of what you're doing and do so in a manner that is interactive so that you can try a thing, see what happened, undo what you just tried and try a different thing, and basically explore in this reactive process where you are making a change, seeing the results of that change, and then making another change after that. And like it's sort of like, on some level, I feel like when people learn about programming, and I'm relating it to programming because that's where I have most of my experience teaching, is teaching programming. When you do it without focusing on a debugger, you how to say it? It's I liken it to maybe painting or doing some other form of art, but without it, or it's like cooking without ever tasting the food, which is something that a lot of folks do actually. And I mean, I say that as though it's like a super obvious thing. Like I also fall into that trap, right? And the reason you do it, or a lot of people do that sort of by default, is because it's not necessarily required to taste the food until you are going to eat it. Or if you're not the one eating it, you don't have to taste it at all. You could just go through this process of making food and then tell yourself, oh, it's good, probably. I followed a recipe that seemed like it was probably good. But anybody that's an experienced cook is going to tell you have to frequently be tasting it so that you can react to how it is actually coming along. You have to, and not just taste it, but you could also like assess the texture of it and touch a thing. If it's like, maybe you're cooking a steak or you're making some bread or something, like use all the senses that you can to get this feedback loop of how is the cooking going? Do I need to change what I am doing? Because following the recipe by rote is not necessarily going to work every time, kind of thing, right? And so, yeah, programming without debugging is exactly that. You are writing code and then just kind of being like, I hope it works, and then you run it and it doesn't, because that's the nature of programming. You're not going to get it right. I don't get it right, and I've been doing it for a long time. And I think every good programmer that I know also doesn't get it right. But they get into the habit of very quickly testing and tasting their code, so to speak, finding out that it's not quite right. And then the sooner you see that it's not quite right, the smaller a change that you have to make, the smaller the adjustment, rather than, I think we mostly were able to avoid it with our students because of the way that we operated the school structure and projects and how much intervention we had as instructors and support staff. But I've heard stories, not like more stories that come from like like academic analysis of the aggregate results of student behavior at universities. And there's definitely sets of students who are like, they operate on the like, they're not going to taste the thing until they've completed the entire recipe. So they write the whole program and then they run it for the first time and it doesn't work. And there's a strong potential that the way to fix it at that point is to throw the entire thing away and start again. Whereas if you wrote like one line of code and then ran it, you would see whether or not that most recent line of code was breaking something. Right? So the longer you wait to test your code, the more likely it is that you're going to have to make a huge change to fix it, including up to throw away all of the code and start from scratch if you literally never tested it the entire time. So I don't remember how I got on that. Oh, the debugger, right? So anytime that you're learning about these details of the thing, you need to be able to see what's going on. And so, the debugger is absolutely a necessary component to how I would teach this stuff, or how I would set up a curriculum that teaches this stuff. Is like, yeah, I think there was a website I was going to go to, which has a decent thing that's along the lines of what I would like to build as a first pass, but it's a combination of, it's at least when I last looked at it, it was almost like just one challenge or one task or something. Like it was relatively devoid of content, and it's also still very, there's actually a few more levels now. There was like one level. I don't know if I'm gonna pay $1,000 for this, but that's neat. Yeah, but so I'm glad that they have more stuff. Maybe they did have it and I didn't see it before. I'm not sure. But they have one level that's available for free. I'm assuming that those are like intended for businesses, but I mean, ultimately it does take a lot of work to build these things. So I'm not terribly surprised that they're charging a lot of money for it. I really need to turn off the, there we go. But you're right. Like if that's expected of some just random person, like I would be surprised if they get too many or anybody paying that, to be honest. But maybe, it's just one of those things where you can convince your boss at work to allow you to get one copy, basically, because you want to learn this skill. Like maybe you already do pen testing or something, and there's an education budget at your company, and they're like, okay, do you want to do another certification or something? And you're like, no, I found this thing and I want to do learning how to do this low level software exploitation stuff. And $1,000 versus however much it costs to get a cert is like, that's, the company's up for it, basically. That's the only context I can come up with for why, like, I don't think any person is going to be like, oh, this has to be so great that I'm willing to spend $1,000 on it. Like, I would not be charging anywhere near $1,000 for my thing. And at the same time, my thing is theoretical and their thing exists. So, apples and oranges. But yeah, so this thing does have, a real debugger, and it's actually interactive. Like, I think I can I delete stuff? No, I can't actually change stuff in here. That's unfortunate. But I think when you're going through the debugger, I don't think it's like a pre-defined kind of thing. I think you can actually use it similar to how you might use GDB. There was a version that was Am I? Oh, okay. Right. So this one is like you need to just enter that. Can I just say, start the program? Okay. What if I'm not in debug mode? I'm trying to remember how this interface works, but I don't remember at this point. Just run. Okay. So if I run the program and then I give the passphrase, give me a shell, right? It's going to read this in, and if it compares equal to that, then it'll just run system bin sh. Yeah, and then we have the shell. So what do I need to do? What is my next step in here? I have lost something. I was able to go through it the last time, but you know, something like this where the idea is it's representing all of the pieces that you would actually do and you can interact with it. My main contention with it, or main difference of opinion about it, is like, this is a much more complicated challenge. This is not where I would start, basically. I think you could design a virtual machine and a programming language for that virtual machine and stuff that are way simpler, but are still, you know, you can see the source code, or you can see the equivalent assembly code. And again, this would be very high level assembly, not like x86 assembly. And you have the debugger, and you know, ideally the debugger would also allow you to like scrub back and forth through history and stuff, and there's a lot you could do there. But I do, broadly speaking, I think this is the right approach for how to teach this kind of thing, because this is not actually running, as far as I know, this is not really running a binary. So it's still simplified, and it's still I don't know, defined in a way that reduces some of the complication. Because like, if you just give somebody a bunch of binaries and say go for it, then they've got the complication of like installing GDB, getting all these tools to work properly on their system. The fact that their system might be configured a little bit differently can have huge impacts on whether or not the exploit works at all, or if it is possible, whether it actually conforms to, you know, how you might have taught them to actually, you know, defeat that challenge, basically. Because like, this is going to run bin/sh. If we needed this to be a set UID binary kind of thing, and our bin/sh was bash, then you need to have a -p. Like, there's a lot of details that can get in the way of making it work smoothly. And by doing a sort of emulated version of the real thing, you can get rid of a lot of those complications. But I also think it would be perhaps simpler to emulate not the real thing, but something much simpler than the real thing. So I think in debug mode, I just have to run it and say, give me a shell. And that does the first step. Okay, cool. And then we need to read the flag file. So we can cat flag. Okay. And now it gives me more, you know, general instructions. And then we can switch to live mode and say, give me a shell, or just run it first. And then cat the flag. And then that's the first flag. Cool. So then I did the first level, or the first chapter, but there was no real, this was not a exploit of memory corruption, at least. Technically the program, this is in that category of, is it really vulnerable, or was the program just designed to run a shell? I guess it needed a password, so us being able to read the source code is what allowed us. We might have had to reverse engineer that if we only had the binary. So that just the, okay, and then we could do Python. Is this a, oh, take a look at the Python tab. Okay, so this is probably, if you want to run the equivalent of like Pwn tools. And see, this is actually Python. So I'm pretty sure what's going on right now is it is talking to a Python interpreter that's running on their server somewhere. And I'm guessing that's why it's taking so long to respond, because they're probably running the server over in the United States and I have a terrible connection to it right now or something. But like, they're not going to emulate, they're not going to emulate all of Python in a, where did that go? I don't know. It didn't print it. Oh, because I didn't say print, maybe? I don't know. But they're not going to emulate Python in JavaScript, I'm pretty sure. Whereas the rest of that stuff was running in JavaScript, if I recall. Because I did sort of investigate how they were doing this by just, peeking in the source code and stuff. So we can run some code. And yeah, it prints A plus B. Okay. So I'll go ahead and link this in the chat if you want to check it out. But I was really quite impressed with the amount of work that was put into this. Like, I don't think I would pay $1,000 to be able to go through this. But it is definitely the most serious attempt at making a smooth version of learning this stuff as possible. Every time that I've done some kind of curriculum around this stuff, there's been so many small pieces of friction about getting the tools right and getting things to work and fit together, and things that aren't the core, that aren't really relevant to the core of understanding how to do the hacking. And they have done a lot of work to eliminate all of that, which is, I think, very admirable. Like, it looks good. I think it is good. And I hope that they are successful in it. I actually met one of the people that works at this place last year at Recon, the reverse engineering conference thing in Montreal. He seemed like a cool guy. I didn't know that this existed, or I would have talked his ear off about it probably at the time, but yeah, it was, I'm glad that I, sort of followed up on the company that he worked at, because that's how I learned about this thing. And I think they had a talk about it at one point where they were like explaining why they wanted to improve on the education material. They are also some of the people that are behind the this, I think I linked this to you the last time, if I'm recalling that it was maybe you that asked, but this GitHub repo, the like modern binary exploitation course from RPI, or the RPI sec sort of group of students at RPI. At least a couple of the people that were the student sort of like not the teacher that was sort of officially involved with the class, but the students that wanted to do the thing in the first place, the people that were doing RPI Sec. Oh, it wasn't you. Okay, sorry, it was somebody else. Basically, they formed that company and they do, I don't know, probably various consulting work, but clearly they are interested in teaching this stuff because they put together this whole course at the school that they were attending at the time, and now they are working on building a very similar course, but even better and like definitely easier to get through than this one in terms of the details of getting set up for it and the educational just, you know, it's just a better curriculum that they've built at this point, I'd say. So I am, you know, I'm really happy that there's other people out there that have the same interest in teaching that stuff that I do. Yeah, I think it was this guy that I was talking with at Recon. So I still have, you know, I have my opinions on why going straight to the real thing is not the ideal learning process, but it's one of these, like, there's trade-offs. If you go with the approach that I've been talking about and advocating, it's going to be a much slower process than trying to go straight to the you know, the real world tasks, basically. Because even though going straight to the real world stuff is more difficult and more likely to be full of frustration and more likely to leave you capable but sort of shaky on some of the understanding, it still can get you to a certain point faster. And that's why, like, when we were teaching at the boot camp, we knew we had a fixed amount of time. We only had 6 months to teach all of this stuff. We didn't spend as much time as I would have loved, and all of the teaching staff would have loved, on some of the, like, core fundamental concepts and really hammering them home. And we just had to hope that by going through the process with some more realistic projects, that there would be a process of osmosis of getting some of those fundamentals a little better than we could teach them in terms of the amount of time that we had to focus on the fundamentals themselves, if that makes sense. So, you know, I think this thing is like $1,000 for 3 months or whatever. Yeah, like you wouldn't want to try and, how to phrase it, you wouldn't want to try and teach in the style that I would prefer to teach if 3 months is your time frame, basically. Do you get ethical hacking boot camps? I'm not sure what you necessarily mean by get. I've never gone to one. I've never really taken any courses or done other education, you know, kind of like self-learning or anything connected to the concept of ethical hacking. As a like, you know, you can be a certified ethical hacker or whatever. So yeah, I don't know. In the boot camp that I worked at was just teaching web development, software development stuff. So no hacking related stuff at all, really. Yeah, $1,000 for 3 months. Whew. You really gotta put your time in when you sign up for that. But, like, you know, a similar thing is like the nightmare course. Like, I feel like I've been learning many of the techniques that they just mentioned in this thing just by going through in trying to complete all the challenges in this course. But it's, how much harder have I made it on myself by taking this route? And also, how much is it possible for me to go that route because of the existing experience that I have, I guess, right? I don't think that just going through all of these challenges in the Nightmare course is what I would recommend to anybody who is beginning, in a sort of beginner point of understanding assembly code or C code, or, you don't, with some of these very early ones, you don't necessarily need to really understand the hacking, the exploitation elements of it, but you do need to have a decent understanding of assembly, I think, in order to get anywhere, particularly, into this section and beyond with it. So yeah, I mean, they do seem to have a. Sure, go for it. They do seem to have a relatively comprehensive course at this point. Yeah, building the shell code by hand. Trying to see if any of these instructions are sticking out to me for what they mean because of my time spent working on the x86 decoder. I feel like maybe 8D8424 is an instruction that maybe the decoder can work on right now, but it's not coming to mind which it is. 48 is maybe a prefix, I don't know. Or wait, 48 is gonna be like an increment instruction. Would be 48 would just be inc RSI. Oh no. Why is it not? Oh, it's decrement EAX. Okay, in 64-bit mode, that's right. This is a Rex prefix of some kind. So yeah, that's the Rex prefix, and this is probably single byte instruction with the mod RM SIB and a 4-byte displacement. Is my guess. I don't know. I'd like to do an on-site boot camp after this whole COVID thing has passed over. Do you think that this looks good, and what do you suggest I learn, as I am quite a noob when it comes to cybersecurity and most coding concepts? Hyperion Dev. I mean, to begin with, I certainly do advocate the idea of the like one-on-one approach. That's sort of the main role that I had when I worked at the boot camp. We had a whole instructional team, and most of the instructors were working on sort of giving lectures and working more in the like teacher role that you would have in your courses at school or whatever. And I was working more as a one-on-one kind of tutor with primarily the students that needed the most support, just based on our assessments as the courses went on, but also just off and on with any of the students who wanted help. And that's where I felt the most effective, at least, because I could sort of really get an understanding of what their thinking was on a particular concept, and so tailor what I was trying to present according to how they seem to be thinking about the concept right now. Because if they didn't have a good mental model for it, and I could help them get to the right mental model for what's going on, that I found to be the most effective, and it works better if I can understand where they're currently at and do that on a like person to an individual basis, that kind of thing. So I do think one-on-one kind of mentorship is good. I mean, it certainly is entirely dependent on the individual that you're working with, and I don't know the standards they have. And I can't speak to the quality of that instruction, basically. I would say 72% within 3 months is... there's definitely other boot camps that have higher percentages, like the one that I worked at. And we, are probably kind of why is that not typing? Why does it do this sometimes? It's like keyboard doesn't work in a particular Firefox window for a second. But this is the boot camp that I worked at, and where are do they still have the outcome results? Apparently they decided not to put it in that. They used to have like info about how many people had jobs after, I think our standard was after 6 months or something. It's probably in here. It's under program. I don't know, but the last time oh yeah, so right, that's in South Africa. I have it becomes really hard to compare those things. Because our rate in Seattle was in the I think it ended up being in the low 90s percentage, which was definitely higher than average for various reasons. But it also helped that we were in a place like Seattle where there's just a lot of software companies, and like Amazon will hire a lot of folks. At the same time, it was like we are, part of it was the design of our school, which is a nonprofit, and the way that we got most of our money was not through donations. It wasn't like a charity kind of nonprofit. Most of our money came from students going to an internship as part of their curriculum. Basically, after the teaching portion, they had a definite 5-month internship before the program ended, and then a lot of them would go on to be hired by the place that they were an intern at. And we needed our students to be really good interns so that the companies would come back and want more interns, because otherwise we wouldn't have revenue for the next class, kind of thing, right? So it was all built around, if the students aren't successful, we aren't successful, which is not exactly how it works if the student is paying a tuition. Like if the student is paying tuition and they aren't necessarily meeting whatever your bar is, but they've already paid ahead of time, or they're locked into paying the remainder of it because they've been in the program long enough, then there's not necessarily a strong incentive to keep them in the program if they're not doing well enough. Or I don't know, like I just think that the design of our situation is a large part of what resulted in that high percentage of getting hired, because we did absolutely everything we could to get those students hired, basically. And it was, it's a lot of work. So, but okay, on the topic of this place, so it really does come down to who is doing this one-on-one education, because I do think that structure is good. And I mean, we can look at the curriculum, right, and try to get an assessment of what they think is worth teaching and what their time frame is for teaching it. So teach Python. What is co-grammar? Okay, so co-grammar is, it looks like a business related to doing like developer assessments, probably for hiring companies or for companies that wish to hire folks. They'll have people do code review kind of aspects of interviews, it seems like. Yeah, how they hire and train developers. So that's interesting. And maybe the dev school is like a offshoot of that. Is like, you know, connected to the school in particular, because I mean they mention it right here, right? So the quality of those teachers, it is a good sign that they have, it seems like they have been trained directly on the idea of being a mentor and code reviewer, which you know, is definitely a skill set that is not inherent in being able to program. So having dedicated some focus on those skills is a good sign. The question mark is this other portion where it says co-grammar runs the most selective program in the world for sourcing and training for this unique career path, which is designed to maximize the success of bootcamp students around the globe. I don't know if this means that they are selecting really great programmers for it, or if they are selecting folks who are intending their career to be reviewing code and helping people learn code, but not necessarily writing a lot of code. At like not working as an active developer, because I'm not sure how much I would agree with that approach. I do think that while the skills involved in mentoring and giving one-on-one support and code review are not inherent in being a good programmer and being an experienced programmer. If you aren't an experienced programmer, I do think that is a detriment to the amount of teaching and mentorship you can provide to the students. So let's see. It doesn't look bad, and honestly, it looks better than a lot of boot camps that I've seen in terms of where their priorities are and their focus on quality of the folks that are working there to support the students. Because in the US there's a lot of boot camps that sort of got in on the fact that this seems to be a at least last year, up through last year, who knows what the situation is with COVID at this point. It was just a very hot field in terms of a lot of people trying to go into these programs, and maybe they'll get a loan or something to do it so you can get a lot of students. And I've heard a lot of stories of like basically the people that were teaching at some of these boot camps were students who had graduated 3 months prior or something and had never actually gone and been working as a professional programmer. And that is very far from the ideal situation for learning, because while they may know the curriculum that has been taught there, they don't know it deeply enough to be able to go beyond that curriculum, not just in terms of what is taught, but how to convey the information. Like, it's not like, oh, they don't know more than that, so they can't teach more than that. It's more like they don't know more than that, so they can't vary how they teach it to make it suit the individual. Basically, a thing that I was reading, it was more about math curriculum, but like a week ago or so, there was a statement in there that was like, a very experienced person shouldn't need a lot of training on how to be an educator in order to teach the skills that they're very experienced in, because they can speak to those things off the cuff directly from their own knowledge and have that communication and that deep connective, like, mental connection with their student or students in a very natural, intuitive way, because they understand it so well because of their experience level. Like, you would want to learn boxing from somebody who had spent a long time boxing. You don't necessarily need to learn it from like Mike Tyson or somebody who's like a championship boxer, but somebody who's been doing it for 10 years or whatever probably has a much deeper intuitive understanding of the things that need to go into it than somebody who's been boxing for a year, right? So, within the context of what they're working with, I do think that sounds like they have a focus on the right things, basically. I would say but this is, see, This is a situation where, like, this is a guy that went to Hyperion Dev and is now a mentor there. It doesn't mention that he went to work anywhere else, and he's been mentoring for 2 years. And I'm not going to say this guy is not good at mentoring, but it would be very helpful. It would improve probably his ability to mentor if he had more real world experience doing software development, that kind of thing. So she's got a master's in computer science. That's nice, but it's also, could mean anything, to be honest. Because it's definitely possible to go through and get a master's degree and a PhD without being a particularly good software developer. Even if you have a really good understanding of the computer science elements of things, software development is almost a lot more about the process aspects of things and working in large code bases and working on teams and all of these things that aren't necessarily skills that come into play in computer science related curriculum. And you can probably talk to a lot of folks about the story, like, who've worked with people who came in and had a PhD and then were like really quite bad at creating the code that they needed to write, even though they know a lot of stuff. It's like there's still a practice there that if you are only doing the academic side of things, you might not be that experienced with. That being said, like, it's also possible to be a PhD and be very good at coding. Like, it's not, it just, having that degree doesn't say one way or the other whether you are a good software developer, I guess. So yeah. So I remember in terms of whether this would be a good thing to do, I mean, it's probably not gonna teach you anything about cybersecurity, it seemed like. You can do web development, you can do software development curriculum, but my experience, none of the curriculum for things that are defined as software engineer or web developer are going to touch on cybersecurity hacking concepts, basically, which is unfortunate, but that's just the reality. And I understand there's not a lot of time involved in these courses, so that's the kind of thing that would easily be cut, even if it were considered, which I think it usually is not considered. In terms of the pricing, I mean, I have no idea what's reasonable. Are these dollar amounts in what do you call it? South African rand? Or are these US dollars? I don't know what the symbol for rand would be. So that's US dollars. So I mean, that is cheap for the US, but I'm assuming not necessarily cheap for South Africa. Oh, and that was the part-time. But it's not really all that much difference. It's about $1,000 difference. So that's 25% more. What I would say is, if you want to go this route, one, you have to, it's a big risk. Obviously, you understand that. And you want to really make a good assessment for yourself a good self-assessment as to your dedication. I don't know, like I don't think I would do well in a like intensive kind of boot camp scenario. I was pretty bad at school, but maybe maybe because it's computer stuff and that just I am so like deeply interested in it, I would have done well in one of these boot camps. That's hard to say, to be honest, but if you've taken computer courses at school and you found that you do put a lot of like you're willing to put a lot of effort into those because you find it fun enough to work on the projects more than is required or whatever, then that probably is a good sign. And if possible, I would think the full-time curriculum is maybe the way to go, just because even though it's like you're trying to then cram it into 3 months for two reasons. One, it's 40 hours a week for 3 months versus 10 hours a week for 6 months. So 60 hours versus 120 hours. Wait, I'm doing, no. 240 hours, right? Versus 480 hours. It's like twice as much. Yeah. You end up getting twice as much time focused on the schooling for 25% more in cost, which is a weird way to assess this kind of thing. Obviously, like time for dollars spent is not necessarily a great metric for something like education. But at the very least, if you're going to do the 6-month thing, you're going to want to spend a lot closer to 40 hours of your own time on it over those 6 months, because I think doing the 10 hours a week for 6 months is not going to get you into that habit, so to speak. If you're going to go and get a job out of this, which is presumably the goal, having the facility to write code, almost like at the, when prompted, basically, let's say, because that's unfortunately what's going to happen in most interviews is you're going to be prompted to write code on the spot, so to speak. If you are writing code, let's say optimally 10 hours a week for those 6 months, and it's probably less than 10 hours because there's all sorts of other elements to whatever the learning process is ultimately, right? Then I don't know if you're going to be like, okay, when it comes down to it, I can just, start writing some code, or I mean, not like immediately write it, but like start developing what the solution is, talk through it, the whole process that you need to go through in an interview. Whereas if you've been doing it for 40 hours a week for the last 3 months, your brain is like deep in it, basically. And so you're going to be in a better position, is my thinking, at least. Maybe I'm just biased because our program, the one that I mentioned, the Ada Developers Academy, was a 40 hours a week kind of situation. It was in person, which, obviously changes a lot compared to this online kind of approach. But it was 40 hours a week, plus a lot of the students spent, significantly more time than that in addition working on their projects and stuff. Like, I think our projects were not necessarily well scaled for the reality of how much time we had set aside to work on them. So probably students spent a lot closer to 50 to 60 hours a week on this stuff. Like didn't really do much else with their life. for those 6 months. They did that for 6 months, which is probably a large part of why the hire rate was so great. Like, that is at that point almost 1,000 hours, and then 5 months of working full time as an intern is is just a lot of experience to pack into a year, basically. So if you think that you could keep up with that pace, because doing this for 40 hours a week is going to be really difficult. It's not necessarily the same as working at a job for 40 hours a week. Well, you've been going to school, so you know the potential for how difficult schooling can be when you're working at it for that much time. Because learning is a very mentally taxing process. And work is going to be that way for, some number of months or year or more when you start off in this career, because you're still going to have to learn a bunch of stuff. The boot camp isn't going to have taught you everything to do your whole job, unfortunately. You'll still end up learning a lot of stuff, but the reality is learning is just a really, it takes a lot of energy to do that. And so you have to make a strong assessment if you're going to go with this program as to whether or not 40 hours a week of that much, mental exertion is something that you are going to thrive under, or if that's going to be more taxing, basically. Because it probably wouldn't help if you go and you commit to something and then it turns out to be too much to maintain and be healthy doing it, and then you have a negative result because of that. And we see all that with some of the students. We tried our absolute best to filter out the candidates that we had based on whether or not we determined if they would succeed under the very strenuous scenario that our school ultimately was, because of how much time they had to focus on learning every week. But even with our filtering, and we only took 10 to 15% of our applicants, there were still folks who it probably was too strenuous of a pace, unfortunately. And some of that came down to they had children or other concerns outside of it that just meant they couldn't spend as much mental effort on it, mental energy, let's say. For sure, I wouldn't say do it while you're at school. I think that would be if you have another big commitment like that at the same time, then absolutely do the part-time first off. So if after school, after you're finished with school and you have to if you have to go work at a job part-time or even full-time, you might still be able to do this, but definitely only do the part-time one. Obviously, I wouldn't say do 40 hours of this and a part-time job. That would be, I cannot recommend that lifestyle, I would say. But maybe do a part-time job and a part-time this. It's just, even under that scenario, you are splitting your energy and then getting less out of this, even though you're paying the same amount, so to speak. The ideal would be to not have other commitments to take away your focus while you're going through this, because you are having to pay, again, the same amount no matter how much or how little focus you can give to the program at the time. What do you think about self-teaching? Because that's what I've been doing now. I mean, that's how I learned pretty much everything. I took a couple of community college courses, but they were all things that I basically mostly knew already. So most of my learning was I'm just self-taught. That being said, it was a very slow process. And I'm lucky that I got started on it very early on. But when you are self-taught, well, you can sort of split the difference there. My self-taught approach was completely freeform, so to speak. Like, I didn't generally go find some curriculum and try to follow that and learn, the stuff that they taught in this series of classes at some university or whatever. I just sort of learned whatever was interesting to me at the time and went with that. So that is a huge component of why it was very slow for me to get to certain things. And so you can definitely improve on that by trying to follow a defined curriculum, since there is a lot of stuff out there, and there's all the like online course stuff like Coursera and whatever the MIT one is, open whatever. So you like, if you wanted to make it more structured and thus a little more time efficient, those are, I think, probably good ways to go about it. And you also have this feeling that like you have the set of things that you've learned is probably a good selection of things because it's been designed by folks who, have an understanding of what probably needs to be taught. But there's a few like issues there. One, if you go to some of these university online courses that you can get for free, their curriculum is focused in a certain way that is different than how a boot camp focuses. A boot camp is probably going to focus on the skills that are going to be most applicable to you getting a job and then doing that job in the immediate term. Whereas a computer science degree has a lot more focus on theoretical stuff and fundamentals, and usually a lot less focus on actually writing code and creating projects to the extent that you can then prove to people in an interview that you know how to write code. You are more banking on the idea that you have a degree that says that you know enough about programming, at least conceptually, to be able to learn how to do the stuff when you get hired. But if you've done that course and you don't have the degree because it was just the online free thing, then you can't bank on that aspect of things, right? And you have to probably do a little more proving that you have some programming experience, not necessarily, obviously not professional experience, but like basically those curriculums aren't as focused on actually writing programs in the same way and to the same degree, is at least compared to what I have seen from boot camps and certainly how our boot camp worked. Like every single week there was another project that the students had to work on, and they were almost always designed around roughly real world programs after the first couple weeks, because for a little while you don't know enough to make anything even close to like a meaningful real world project. But like we had a project that they worked on that was actually a 2-week project, which was like building a e-commerce site that was similar to Etsy, if you know that from, I don't know if they have it out there. But like things like that are real world rather than like focused around particular data structures or like, hey, let's build a mini operating system or something. Not that, building a mini operating system to learn those principles of operating systems is bad, but it's also still pretty far from the real world of how operating systems are developed and actually created. And certainly unlikely to be what you would be doing in your job as your average software developer. Most software developers don't work on operating systems, for example. So, you have to keep in mind what the focus of the curriculum is. That being said, there are probably also free boot camp style kind of focused education. There's like free boot camp, which is a JavaScript thing. I don't know how comprehensive it is, but it might be a way to start off. And I'd say regardless, like whatever self-learning you do, if you still want to go to this program at some point in the future, that time that you spend teaching yourself is only going to help. in making this a more effective time and in making the most out of the money that you have spent, the money and the time that you've invested in going to the school. Because unless you know so much that you can get a job already, whatever you already know is going to help you go through this curriculum and get the most out of working with the mentors as possible, because you don't have as far to go, I guess. Okay, and then on the idea of the slowness, and I think this is probably, I'm gonna probably end the stream after this. Unfortunately, it has been me talking for like 4 hours straight, and I'm just getting, I don't know, a little like I need to go to sleep. Even though my learning process was a very slow one, yeah, I know. I didn't get up to go get another water bottle, so I've been just slowly getting more and more dehydrated from all the talking. Even though my teaching process, or sorry, my learning process has been a very slow one, there is a benefit to learning something slowly. There is an unconscious element to all kind of learning, I would say, and this is purely my own like speculation, opinion, whatever, but like your brain does a lot of work on its own to build on the knowledge that you have received through the intentional process of learning. And I think what has allowed me, so when I first got a job programming, or rather when I was first like moved into a role where I was programming as my primary thing for my job, I had pretty much never built a serious, I built maybe one real world application, and it was pretty small in reality. It was like taking an existing like bug tracking system and turning it into a ticket issuing system. Not a ticket issuing system, but like a job tracking system that just basically filled out a PDF. I found some PDF library. It was like a PHP application that I made, or I really just built on top of this existing software and integrated a little bit of thing to generate a PDF document and print it out so that our hardware or like computer repair company could have an online database of all the customer orders that had come in. Basically, you'd fill it out on the computer, and then you could print off the PDF because they were already working off a basis of using a paper-based form for everything anyways. So I made it so that you could generate the form from the database entry, and you could track the progress of stuff on the online system. Of course, they never used it, actually. They wanted to use it, but then they didn't change their process very much, so they didn't end up integrating using the online tool, which is weird to me since it's a computer shop. You'd think they would be a little more prone to using computers, but whatever. That was the only real software that I had made, and it was pretty minimal. But I think my ability to scale up to the size of the game project that I worked on, which was millions of lines of code, was in large, like I was able to do that relatively quickly, I would say, because over those years where I wasn't doing any big projects, I wasn't like, writing a lot of code really. I was learning all these little sporadic pieces of things, and over that time period, my brain was connecting these things and building a base of knowledge and a base of like, I just have these random little facts that I've been able to connect to other little random facts that I've learned, basically, to, I don't know, build a net of like connections that supports later building more concrete skills, so to speak. So like I don't think that process would have worked if it didn't take as long as it ended up taking. So there is some benefit to going the slow route. But of course the cost to that is do you have the time? And I was just very lucky that I started on that very slow route when I was realistically like 8 or 9 years old. And then much more concretely, when I was like 15 and on, right? So taking 10 years to get to that point is maybe reasonable when you're a kid and you aren't paying for your own existence. I don't know, like way back in the day in Windows 95 they had this like Q basic program that was just on the desktop, and I double clicked on it one day and was like curious enough to learn about Q basic, and then my parents were really supportive of that and sent me to some like computer camp for summer one year, and it was basically over for me at that point. I want to be clear. I did not make anything meaningful at that age. I was actually very impressed with some of the other students who went to that computer camp and had like real good programs. I always felt like, oh shit, I thought I knew how to do this stuff. And in fact, when I went to that computer camp, they had a class on C programming, and I distinctly remember going, because I had just done basic, and so I went to the C program, and they were talking about the stack and the heap, and none of it, 0% of it made any sense to me. And so for the longest time, I just remembered like, oh, there's this thing called the stack and this other thing called the heap, and I, just nothing, none of that meant anything to me for a long time. In fact, I would say I wrote, some amount of C++ code before those things ever made sense to me. And certainly I wrote a significant amount of C++ code before I came to a deep enough understanding to say that I actually understand those things. But that's the thing with the slow route, right? Is like you don't understand until suddenly you do, and it's hard to pinpoint how that change happened, because I think it really is built on this unconscious process that your brain is going through on your behalf of like, I don't know. I think it's one of those like the same reason that people believe in conspiracy theories is like your brain desperately wants to understand. And so it will take all these little bits of things that you do not understand on their own and will attempt to find a connection and find a way of fitting them together to make an understanding out of it. In the case of a conspiracy theory, you end up, generally speaking, with nonsense, because those things actually are not connected. But in the case of, learning about some particular field, like programming, a lot of these pieces are connected in some manner or other. And having exposed yourself to all these like random bits of information that actually do have connections becomes meaningful. And I would say if I want to be charitable about it, my approach to learning this stuff, and it was never obviously an intentional approach to be like, kind of learn stuff very slowly and haphazardly, but one of the benefits of this approach is I just have a much broader set of experience than somebody who is at the same, level of professional experience as I was at, when I started my first job or whatever, right? When they start their first job, they've understood everything, unless they did a lot of work on their own. If they went through university curriculum, they understood things primarily or solely from within the context of that curriculum. Whereas I dabbled in all manner of weird stuff and like, game engine or like sort of game hacking kind of stuff and like game server emulating and whatever just seemed interesting to me at any given moment. And so I learned a weird mix of like high level and low level concepts and networking stuff and this and that. And being able to like, it was the end result of that was anytime I was encountering a new thing, there was almost always some piece of a small thing that I had experienced before that I could sort of relate to whatever this new thing was. And that is beneficial. But it's also, it's hard for me to recommend that to anybody just because the time trade-off is really a pretty intense one. So I don't know. I think, going to a boot camp after school, after you finish out with school, is not an unreasonable choice. Programming is, I'm assuming you're not going to school for computer science or something, right? You mentioned maybe being too young, so I'm assuming it's maybe like the whatever they call the pre-university school over there. So, certainly I wouldn't say you're too young if you have graduated from high school. Yeah, then sure. I would say a lot of what programming is in the real world fits more in the concept of a trade craft, like plumbing and carpentry and electrician stuff, than how you might come to think of it if you just see the fact that it's taught at universities alongside biology and astronomy and all of that. There's you can absolutely learn it at one of these schools and be an effective and skilled programmer. So don't look at it as like, oh, is this, a bad route to go because it's not a university. That's not how I would look at it, at least. Yeah. I mean, obviously, I'm biased because I worked at a boot camp, so I've seen how it can work. And I think the degree to which you end up as a good or great programmer or whatever out of one of these boot camps is mostly about your own passion and willingness to continue working on your skills and improving your skills beyond going to the school. But that's going to be true whether you went to a university or not. So it's just, these cost a lot less than a university. And they're a lot more focused on learning the thing that you're going to do in your job rather than sort of getting this well-rounded, whatever they want to call it. I don't know. I'm not a big fan of universities, I guess, as a default thing that everybody needs to do. I think it's unfortunate that at least in the US, that's basically how it's worked out. And it's mostly a scam. I think at least I've talked about that on stream before. And it's not that they're bad, but I think it's not a thing that most people really need. And this assumption that like, oh, it's important for you to have had this and that experience or have learned these general education topics about literature and et cetera, like, no, I don't think that's necessarily the case for everybody. And if those are things that you're interested in, it's not like you can't learn about literature outside of a university or whatever, right? Okay. This has been a long session of just me talking rather than hacking. So I think tomorrow we'll get, I don't know, maybe we'll do the x86 instruction decoder because I didn't do it yesterday. So I don't want to go too long without doing it or I'll completely forget what the code is. And then, yeah, we'll get back to some hacking on Friday, I think. But I'm glad that I took the time to sort of pontificate about my ideas of building a hacker curriculum And we'll see if that ever comes to a point where I'm actually working on the things related to doing that. And I appreciate everybody who is talking with me in chat or just watching the stream. Julian earlier, hopefully you can look at the VOD and get that last little bit of information about the ROP chain, and maybe we can talk about that more on the next stream or on Friday. And then Foon, of course, thanks for coming in and chatting with me and having a discussion about education and all that. So yeah, of course, very welcome to answer your questions, man. To the extent that I am able to, at least, yeah. All right, this is it for me today. So adios.
Ain't going back. It doesn't matter if it's true. I've got a feeling love will give us what we lack. The world is waiting up. The world is waiting half a step beyond our door.